One of the most basic input devices on a computer is a keyboard. A keyboard is a device that is used to input commands to the computer. It has keys that are made up of alphabets, numbers, and symbols that you can press with your fingers. The most basic function of a keyboard is to do things like word processing, write letters, emails, visit web pages, and so on. Keyboards come equipped with two different connector types. There's the older 6-pin DIN connector, which has pretty much become obsolete, and there's also the modern USB connector. A lot of keyboards will have the ability to use both connectors because a lot of times they will come with a DIN to USB adapter, which you can use with any computer with either a DIN or USB connection. A mouse is another basic input device that is used on a computer. It's a pointing device that fits in the palm of your hand and replicates the movement of the mouse onto the computer screen. It's used for things like starting applications, file and folder management, and surfing the internet. A mouse will typically have 1 or 2 buttons. A Macintosh mouse will have 1 button, while a Windows mouse will have at least 2 buttons. A digital camera is a device that takes digital pictures and videos. And unlike standard cameras where the images are stored on film, a digital camera stores the images on an internal hard drive or on the camera's SD card. And once the images are stored, they can then be downloaded to a computer by using a USB cable or by the SD card. And then once they're on the computer, the images can be viewed or printed. A barcode reader is a device that is used for reading barcodes. It uses light to scan barcodes, and it's typically used to detect point of sales and maintain inventory. It can connect to a computer through a serial port, USB port, or a wireless connection. Barcode readers can come in several forms, but the most popular is the handheld trigger type. Now, a scanner is a device that enables you to put a digital copy of a physical copy on your computer. So, for example, if you have a photo or a document and you wanted to put a digital image of that photo or document on your computer, well, that's what a scanner enables you to do. Scanners would typically have a flat bed where you can place the photo or document face down, and at the press of a button, it will scan it for you. And as the scanner moves across the document or photo, it saves the image to your computer. Scanners will typically come in a combination with a printer, or you can also purchase a scanner all by itself. A touchscreen is basically an LCD monitor with an input detection system. It's a grid that senses the touch by a finger. It works the same way as if you were using a mouse, but without the mouse itself, because you are using your finger instead. The touchscreen receives a touch in the same way as if you were clicking a mouse button. Typically, 1 click on the mouse button equals 1 tap by a finger, and 2 clicks of the mouse equals 2 taps by your finger. Touchscreens are commonly used in all-in-one computers and tablets, such as the iPad, and they are also used on certain phones with touchscreen technology. A webcam is a device that is used for capturing video and images. Webcams are mainly used for video conferencing and video calling over the internet. So any 2 people in the world can visually communicate with each other if they both have a webcam and an internet connection. And most webcams have a built-in microphone to capture audio. A webcam connects to a computer typically through a USB cable. and webcams are often used with messaging applications such as Skype for making visual calls. And two of the biggest manufacturers of webcams are Logitech and Microsoft. A media card reader gives the computer the ability to read memory cards from devices such as cameras. It's a small device that usually has a USB cable attached at one end that connects to a computer. And then the body of the reader has slots to accommodate various sizes of memory cards. For example, micro SD and mini SD cards. And then once installed, the data from the memory cards can be read and transferred to the computer. A docking station is used for laptop computers. It's a device that is used for basically turning your laptop into virtually a desktop computer. We all know that laptops are generally smaller than desktops. For example, on the laptop, the monitor and keyboard are generally small. So if you wanted to use your laptop at your desk, and you wanted to use a bigger monitor and keyboard, you can simply set the laptop in the docking station and it will automatically connect to them and use them depending on what is already plugged into the docking station, whether it's a monitor, keyboard, mouse, printer, etc. It eliminates the hassle of connecting all these individually. You just simply attach and then start using them instantly. But there's one thing to remember about docking stations, is that they are specific to the manufacturer. So there is no such thing as a one-size-fits-all docking station. You need to get the specific one for the laptop. A KVM switch allows you to control multiple computers from a single monitor, keyboard, and mouse. A KVM is typically a box with ports for a video, mouse, and keyboard. Each computer has their own individual cable connections to the KVM. Each KVM has buttons that you can press so that you can switch to a different computer you want to control. KVMs also come in different sizes, depending upon how many computers the KVM can handle. A low-end KVM switch will have the ability to control 2 computers, while a higher-end KVM can control 8 computers. KVMs are handy when you want to control multiple computers without the need for a dedicated monitor, keyboard, and mouse for each one. This not only saves money, but it also saves space. A lot of TVs today are smart TVs. A smart TV is a television where you can not only watch TV, but you can also connect to the internet. So basically it's a television combined with a computer. And when it's connected to the internet, you can go to web pages, stream movies, and television shows. And you can also interact with other people across the internet by using video messaging services such as Skype, because a lot of smart TVs will also have a built-in webcam and a microphone. One way to prove the identity of a person is by using a smart card. A smart card is a good choice to prove your identity because you always have to have it with you when proving your identification. A smart card is the same size as a credit card with an embedded microprocessor chip. And a smart card reader is a device that is used to accept and read smart cards. A biometric device is used to prove the identity of a person by recognizing unique physical characteristics. For example, a fingerprint scanner. Fingerprint scanners are used to read a user's fingerprint to prove authentication. And these days, a lot of fingerprint scanners will be built into a device, such as a laptop or a smartphone. You just swipe your finger across the fingerprint scanner, and the scanner will either grant or deny you access based on your fingerprint. Another type of input device is a motion sensor. And a motion sensor records your hand movement in mid-air without making any physical contact with the device. A motion sensor would also typically connect to your computer using a USB cable. Now, a digitizer is a device that is used to convert analog movement, such as a hand drawing, and convert it into a digital form on your computer. A digitizer will have a flat surface like a tablet with a stylus, and as you draw on the flat surface using the stylus, it will record the image from the stylus and process the drawing on your computer screen. A digitizer typically connects to your computer using a USB cable. Other input devices include gamepads and joysticks. Now, these are controllers that you would typically use for gaming systems, such as Xboxes and PlayStations. But you can also use these for computers. And if you're going to use these with a computer, they would typically connect using a USB connection. A computer monitor is the primary output component of a computer. It connects to the computer's video adapter through a monitor cable and displays images on the screen. A computer monitor may have a VGA, DVI, HDMI, or a display port. Now, an older type of monitor is called CRT. CRT stands for cathode ray tube, which was the technology first used in TV sets. These monitors are bulky and heavy and take up a lot of desk space, and they are pretty much non-existent in the marketplace today. An image is produced on a CRT by using 3 color electron guns. These colors are red, blue, and green, which, when you combine them, they are able to produce any color on the color spectrum. And these guns shoot beams of electrons on the screen and create an image that we see. These beams repeatedly sweep across the face of the monitor many times per second. So it's constantly redrawing the image that we see on the screen. And this redrawing of the image is known as the refresh rate. And the refresh rate is measured in hertz. So for example, if the refresh rate is 60 Hz, then that means that the beams sweep across the entire face of the monitor, redrawing the image at the rate of 60 times per second. Now, to the naked eye, most people cannot detect this because it does it so fast. But a lot of times, some people complain of discomfort in their eyes because they are noticing this constant refreshing of the image. But this problem is usually solved by increasing the refresh rate, which makes the refreshing of the image less noticeable, which reduces the amount of eye discomfort. Inside CRT monitors is a metal plate called a shadow mask, and this metal plate can pick up outside external magnetic fields, which can cause discoloration on the screen. And because of this, CRT monitors need to be degaussed. Degaussing is the process of getting rid of the unwanted magnetic fields, and most CRTs do an automatic degauss when the monitor is turned on, or the monitor may have a button that you can press to do a degauss. Another type of monitors are LCD, which stands for liquid crystal display. LCD monitors produce an image on a flat surface by using liquid crystals. Light shines through these crystals to produce an image on the screen, and it uses filters to produce different colors. LCDs were first used in laptop computers, and now have made their way to the desktop marketplace and have completely replaced CRT monitors. They are lighter, thinner, use less power, and take up less space than CRTs. LCDs are also known as flat panel displays. Modern LCDs use a technology called TFT, which stands for thin film transistor. And as the name implies, this technology uses a thin film transistor to create a higher quality image when compared to a standard LCD, because each single pixel on the screen has its own transistor, and all LCDs sold today have TFT technology. Now there are two different types of LCD monitors that you're going to need to know for the exam, and one of them is called TN. TN stands for Twisted Pneumatic, and this type of LCD monitors works by liquid crystals actually twisting the light as it comes through. Now TN is an older and cheaper technology that's been around for several decades. The viewing angles and the color reproduction on a TN monitor are not as good as a more modern LCD monitor. A TN monitor is often used with calculators, digital watches, and older LCD monitors. Now a newer and more modern type of LCD monitor is IPS. And IPS stands for in-plane switching. This type of monitor works by, instead of the liquid crystals twisting like in a TN monitor, the liquid crystals in an IPS monitor stay in place and are aligned in parallel with the glass. IPS LCDs use more transistors than a TN monitor, so as a result it does consume more power. IPS monitors were designed to improve on the limitations of TN monitors. They offer better color reproduction and better viewing angles. In order for LCD monitors to show an image on a screen, it needs a light source. And there are a couple of types of backlighting that an LCD monitor uses. And one type of lighting is by using fluorescent lamps. These fluorescent lamps are the circular straight tubing types, similar to the regular fluorescent lamps that we're all used to seeing. These lamps emit ultraviolet light that's created when the mercury vapor inside the lamp is ionized. And another type of backlighting that LCD monitors use is LED. LED monitors use multiple light-emitting diodes that are arranged in a pattern that displays the images on the screen. Now this is a more modern form of backlighting compared to fluorescent lamp backlighting. In fact, most, if not all, new LCDs today use LED backlighting. Now both of these monitors are considered LCD monitors, but the LCD that uses the LED backlighting is considered an LED monitor. So an LED monitor is just an LCD monitor that uses LED backlighting. Resolution is defined as a number of pixels that are used to display an image on the screen. For example, if a monitor is set to a resolution of 1280 by 720, then this means that there are 1280 horizontal pixels by 720 vertical pixels, which means that there are 921,600 total pixels that are being used. The higher the resolution, the higher the number of pixels will be used, which means a clearer and sharper image. Depending upon the hardware and software being used, resolutions can be set anywhere from 640 by 480 up to 1920 by 1200 or more. LCDs produce their best quality image when they are set to their highest resolution, which is called their native resolution. Resolutions are also given different names for identity purposes. For example, XGA stands for Extended Graphics Array. This has a resolution of 1028 by 768. SXGA stands for Super Extended Graphics Array. This has a resolution of 1280 by 1024. SXGA Plus stands for Super Extended Graphics Array Plus. This has a resolution of 1400 by 1050. UXGA stands for Ultra Extended Graphics Array. This has a resolution of 1600 by 1200. And WUXGA stands for Widescreen Ultra Extended Graphics Array, and this has a resolution of 1920 by 1200. And lastly, the contrast ratio. The contrast ratio refers to the contrast between black and white. The higher the contrast, the better the display. Printers allow the ability to print copies of documents or pictures onto paper from a computer. There are several different ways that a computer can connect to a printer. The most common way is by using a USB or parallel cable. This is known as a local connection because the printer is directly connected to the computer. But you can also connect a printer through a network if the printer has a network interface, such as an Ethernet port or a wireless antenna. These are known as network printers. Network printers are convenient because the printer can be placed anywhere in a home or office as long as it's connected to the network. Another method of connecting is through a network share. For example, you can allow other computers that are on your network connect to your local printer by sharing your printer over the network. So after the printer share setup is complete, the other computers can now print to the printer that is connected to your computer. So your computer basically acts as a gateway for other computers to access your printer. But the drawback is that your computer has to be on in order for others to use your printer. There are several different types of printers. There are non-impact printers and impact printers. Non-impact printers print without striking an ink ribbon onto paper. These include laser, inkjet, and thermal printers. Impact printers are dot matrix printers, which we'll talk about shortly. Inkjet printers are the most common printers that are used for home use. An inkjet printer works by the printhead moving back and forth across the paper during printing. During this process, the printhead places ink on the paper in very tiny dots. In fact, these dots are so tiny that they are smaller in diameter than a human hair. And as these dots are precisely placed, they form to create an image on paper. Inkjet printers typically come with two ink cartridges. One is for color and the other is for black. Inkjet printers are more affordable than laser printers, and they can produce photo quality results. But one of the drawbacks is that the ink from an inkjet printer may smudge, while ink from a laser printer does not smudge. The next printers we're going to talk about is laser printers. Laser printers come in different sizes, from small personal ones to larger ones for businesses. Laser printers provide the highest quality print available today, and they are the most expensive. A laser printer basically works by placing an electric charge on a rotating drum. Then a laser discharges a lower electrical charge on the drum. So basically, the laser draws the image that is going to be printed on the drum itself. Then the drum is coated with a fine black powder known as toner. And as the drum is being coated, the toner only clings to the areas where the laser has drawn. Then as the paper goes through the printer, the toner is placed on the paper. And the result is a high-quality print that is second to none. Another non-impact printer is called a thermal printer. Thermal printers print by using heat. Thermal printers use special print paper called thermal paper, and on this thermal paper is wax-based ink. And when heat is applied to this ink, it turns black. So in a thermal printer, the only thing the printhead does is apply heat to the areas where the ink should be placed. Then, when the ink is cooled, it becomes permanent. And because of this technology, thermal printers are very quiet. Thermal printers are commonly used for printing labels and barcodes. Dot matrix printers are almost non-existent today. They are an old technology that produces mediocre print quality when compared to laser or inkjet printers. And they are also very noisy. Dot matrix printers are impact printers. The printhead in a dot matrix printer moves across the paper, and as it moves, the pins on the printhead strike against a cloth ink ribbon, which then comes in direct contact with the paper, producing each character in the form of dots. But despite being an outdated technology, dot matrix printers can print multi-copy documents, such as carbon copies. They are also very durable and last a long time. Several issues are going to happen when you're printing. So for example, if you're printing something and you see streaks, well then this could be a problem with the ink cartridges on an inkjet printer. A lot of times the software that comes with the printer will have a list of software tools that you can use to clean the printhead. Or if the streaks are real bad, you may have to remove the ink cartridges from the printhead and manually clean them with a lint-free cloth. Or another problem that can happen is when you try to print something and the image is faded or it's completely blank. And this could also be a problem with dirty ink cartridges, or it could be something as simple as maybe you're low on ink. Now, ghosting is another problem that can happen with laser printers. Ghosting is when you see a faint image of a page that you previously printed and you see the same image on a newly printed page. And this is usually caused by the drum or the fuser. The drum on the laser printer has a lifespan after so many prints, and then you have to replace it. So you can try replacing the drum, but if you still see the same problem after you replace the drum, then the problem could be the fuser. So then the fuser would have to be replaced. Paper jams are another problem that can happen with printers. So if you try to print something and the paper doesn't come out, well then you could have a paper jam. Paper jams could be caused by debris inside the printer. And debris inside the printer could also be the result of the paper coming out creased. Or it could also be caused by faulty pickup rollers. Now this typically happens with older printers, because when the rollers wear out, they tend to have difficulty grabbing the paper and feeding it through. So in these cases, you might want to inspect the rollers to see if they need replacing, or open up the printer and check for any debris inside the printer. Another issue is if you're printing something and the color may not be printing correctly. And all this could be is that maybe that one of the color ink cartridges are faulty, or they are low on ink or even out of ink. A lot of times when you're trying to print something and then absolutely nothing happens, well then this could be a connectivity issue. Connectivity issues are extremely common, especially when you're dealing with network printers. But the first things to check are the obvious ones. For example, make sure the printer is actually turned on. Or check for any errors on the printer's LCD display if it has one. Or if the printer has a wired connection, then make sure that the network cable is connected correctly. You should always check the obvious things first before diving into the more complicated issues, such as seeing if the printer has an actual IP address. Because doing the simple and obvious things first will save you a lot of time. Instead of printing a document onto physical paper, you can also print your document and store it on your computer in a digital form. And this is called virtual printing. Virtual printing is done for several reasons. And one of those reasons is called print to file. Print to file saves the document in a ready-to-print format that another printer can print. So for example, if you want to print a document and you don't have a printer, well then you can use the print to file feature and it will save the document in an uneditable digital form that can be sent to another computer, for example maybe through email or a flash drive transfer, and then that computer can print the job for you. Another form of virtual printing is called print to PDF. PDF stands for Portable Digital Format. Printing a file to PDF prints a virtual document into a format that's universally readable across all devices, whether it's PC, Mac, or smartphones. And then once it's printed to a PDF, the file can be transferred to different devices, such as through email or through a flash drive. And because the PDF format is so common, just about every new device on the market today will be able to read a PDF file without adding any additional software. But older devices may need additional software installed in order to read a PDF document. The most common PDF reader is Adobe Acrobat Reader, which is available free to download. A computer has basically two types of memory, primary memory and secondary memory. Now, primary memory is temporary, which we'll talk about later, but secondary memory is permanent, and this deals with the hard disk drive. The hard disk drive is a sealed case that contains magnetic disks, and these disks is where the actual data is stored on. These disks rotate at high speeds, and as they do, the actuator arm will either write data to the disks or read data from the disks, depending upon what the user wants to do. These magnetic disks can rotate at speeds of either 5400, 7200, or 10,000 RPM. The typical hard drive that's used today in desktops would operate at 7200 RPM. Cheaper desktop hard drives would operate typically at the 5400 RPM range, which is also the speed of a typical laptop hard drive. And the higher end hard drives would operate at the 10,000 RPM range. But these higher end hard drives are not commonly used anymore because of the advanced speeds of solid state drives. And also hard drives are considered non-volatile because they can retain and store data when not connected to a power source. Hard drives today use the serial ATA interface. Now this is a newer standard that is faster than the old parallel ATA interface. Instead of data traveling in a parallel path, the data travels in a serial path, which means that data travels one bit at a time. SATA drives have transfer speeds averaging 6 gigabits per second, which is considerably faster than the old parallel ATA. Other advantages of SATA drives is that they are hot swappable and the cables are a lot smaller, which makes cable management a lot easier. Another type of storage device is a solid-state drive. Now these drives have no moving parts. This type of drive uses flash memory chips to store data. And since it has no moving parts, the data transfer is very fast. There are also drives out there that combine the use of magnetic disks and flash memory, and these are called hybrid drives. Hybrid drives takes advantage of the large capacity and the low cost of magnetic disks with the speed of an SSD. In a hybrid drive, the magnetic disks will be used to store data, while the flash memory would be used for the caching of the data. Hybrid drives are primarily used where cost is an issue, because SSD drives are considerably more expensive than magnetic disk drives. Removable storage is both convenient and portable because these types of storage are not stored internally in a computer. They are attached from the outside. So for example, a tape drive. A tape drive is an inexpensive way to back up data from your hard drive. It attaches to a computer, usually with a USB cable, and the data is backed up sequentially to tape, which basically means that if you ever have to restore the data, you have to restore the data in the same order as you backed it up. CD-ROM drives have become a standard component in computers today. It's a device that reads data from a CD-ROM, which is a disk that stores permanent data. CD-ROM stands for Compact Disk Read-Only Memory, which means that the data can only be read to and cannot be changed or written to. CDRW stands for Compact Disk Rewritable. A CDRW drive can change or write data to a CD. It has a moving laser assembly that writes or burns the data to a CD. Now there are two different kinds of CDs that can be written to. A CDR, which stands for CD recordable, or CDRW, which stands for CD rewritable. Now CDRs can only be written once too, but a CDRW allows data to be rewritten multiple times. And CD-ROMs hold approximately 700 megabytes of data. A DVD-ROM drive is a device that reads DVD discs. The DVD drive has largely replaced ordinary CD-ROM drives because of the larger storage capacity of DVD discs. A DVD can store approximately 4.7 gigabytes of data. And all DVD drives today can read both DVD and CD-ROMs. And like a CD-RW drive, there is also a DVD-RW drive. And this can change or write data onto a DVD. It can write data onto DVD-R discs and rewrite data onto DVD-RW discs. And as stated previously, a DVD disc can hold approximately 4.7 gigs of data. And some DVD burners have the capability of burning dual-layer DVDs. And these are called dual-layer DVD-RW drives. Dual-layer DVDs have two recordable layers, so they can store nearly twice the amount of data than a regular DVD. Dual-layer DVDs can hold approximately 8.5 gigs of data. Blu-ray is the latest optical drive to date that was released in 2006. Blu-ray will eventually replace the DVD format because of its high capacity. Blu-ray uses a shorter wavelength laser compared to DVD, which allows a Blu-ray disc to store far more data than a DVD. A standard Blu-ray disc can hold 25 gigabytes of data, which is 5 times more than a DVD. Now, just like CD recordable and DVD recordable drives, Blu-ray also has a recordable drive, and this is called BDR, or Blu-ray Disc Recordable Drive. And this is where you can burn data to a Blu-ray disc one time. Or you can also erase data and overwrite the data on a Blu-ray disc using a BDRE, or Blu-ray Recordable Erasable Drive. So as stated before, standard single-sided Blu-ray discs hold 25 gigabytes of data. Or there's also Blu-ray double-layer discs, which hold 50 gigabytes of data. Another type of removable storage is what's known as a solid-state disk. Now these have no moving parts. This type of memory uses memory chips to store data, and these include thumb drives. A thumb drive is a miniature storage device with a USB interface. These devices can store anywhere from 500 megabytes up to 256 gigabytes, and their size is small enough to fit on a keychain. These are a fast and convenient way to store data on the go. Secure digital or SD cards are a popular type of flash memory. Now these are primarily used in digital cameras for storing photographs and videos. Then these photographs and videos can then be easily transferred to a computer with an SD card reader interface. SD cards come in various capacities, anywhere from 2 GB up to 512 GB. Other types of SD cards include the mini SD and the micro SD, and you can see the comparison of the different sizes here. And while the standard SD card is used for storage in a lot of digital cameras, the micro SD card is what's commonly used in smartphones for adding extra storage. Another type of flash drive that is commonly used in a lot of DSLR cameras is compact flash. Compact flash cards provide quick and easy storage for pictures and videos in DSLR cameras, and they can be easily transferred to a computer by using a card reader. And a type of non-standard SD card would be the older XD picture card, where XD stands for Extreme Digital. And this was a type that was proprietary in Olympus and Fujifilm cameras. The kind of memory that you would typically find inside smartphones and tablets is called eMMC. eMMC stands for Embedded Multimedia Controller. eMMC consists of putting flash memory and a flash memory controller into one package. So this is the tablet's or smartphone's internal or embedded memory and not the external storage like an SD card. Now a hot spare is defined as equipment that can be swapped out without the need of turning off the power. So for example, if you had a server with multiple hot swappable hard drives, and if a hard drive were to fail, you wouldn't need to shut down the server. You would just simply remove the hard drive and replace it with a new one while the power is still on. Now a cold spare is similar to a hot spare, but with a cold spare you must turn off the power first in order to replace the piece of equipment. You may come across issues when you're dealing with mobile devices such as cell phones. And two of the biggest cell phone operating systems are Apple and Android. A lot of cell phones today are touchscreen, and one of the common problems you may encounter with touchscreens is that sometimes they are not responsive. You touch the screen and nothing happens. So when this happens, the best thing to do in this case is to power off the phone and then turn it back on. And a lot of times this does fix the issue. Or if you power it back on and you still have the issue, you can try and eject the SIM card and then putting it back in. Or if that doesn't work, then you may have to do a hard reset on your cell phone. And you can refer to the manufacturer's documents for specifics on how to do a hard reset for your specific device. Or sometimes you may have issues when you touch an app and the app won't load, or you may have an issue with the performance of your device and you find it to be running very slow. And a lot of this is caused by having too many apps open already, and those apps are eating up memory and CPU resources and slowing down the performance of your device or even freezing it. So the first thing you should do is to try to kill any apps that you have open and see if that fixes the issue. For example, on an Apple device, the way to close apps is to double-click the Home button and to swipe up each app that's open, and it will close the app. Or if that doesn't work, then you can just try and restarting your device. In fact, you'll find that just restarting your device fixes a lot of issues. Also with cell phones, you may encounter issues where your GPS is not working. Certain applications on your phone require GPS. So if a certain app is not working, it could be that your GPS is turned off. So the first and most obvious thing to do is to go into the settings on your phone and make sure that the GPS is turned on. Or if you find out that your GPS is turned on and you're still having issues, you have to remember that your GPS uses satellites for communication. So for example, if there's a cloudy day, then that could interfere with satellite communication. Or maybe there's a spaceship passing by, and that could also interfere with GPS satellite communication. Now, as far as troubleshooting issues with laptops, one of the main problems, when you turn the power on, your screen is blank. Nothing shows up on the screen. Now, you may hear the fans running, and you may see the LEDs turn on, but your screen is still blank. And this is called a no display issue. Now, this could happen for a few reasons, but the best thing to do right off the start is that if you have an external monitor, go ahead and connect an external monitor to your laptop and see if an image shows up on the external monitor, because most, if not all, laptops will have an external video port on the side of a laptop where you can hook up an external monitor. Now, if an image does show up on the external monitor, then that most likely means that your LCD monitor on your laptop is bad and it needs to be replaced. Another problem is that when you turn the laptop on and the image is very faint, in other words, the display is very dim, and in this case, most likely, you would have to replace the inverter. The inverter is a small circuit board that supplies power to the LCD monitor. It converts DC current to AC current. The inverter is usually mounted inside the display panel just below the screen. You may also encounter an issue with your laptop where the battery is not being charged. Now, your battery is in the laptop and a battery charger is plugged in, but you'll notice that there's an indicator informing you that the battery is not charging. Now, most likely this could be a problem with the battery itself, and it needs to be replaced. Or it could also be a problem with the laptop's motherboard. Or in another scenario, let's say your battery is fully charged, but the battery only lasts a few minutes before it discharges. Now, this is a very common issue with older laptops. Oftentimes, when laptops reach around 5 years old, the battery will only last on a few minutes on a full charge. For example, they may only last about 10 minutes on a full charge. And this happens because batteries lose their capacity to hold a charge as they get older. So to solve this issue, all you have to do is just replace the battery for the laptop. Now, if you press the power button on your laptop and nothing happens, in other words, you don't see any power LEDs, your screen is totally blank, and you don't hear any fans turning, well then one of the first things to check is to make sure that your battery charger is plugged into the wall and at the other end is plugged into your laptop. And once you verify that and still nothing happens, then most likely you have a dead laptop. In other words, the motherboard is dead and needs to be replaced. A flickering monitor can also be related to a bad LCD or inverter, especially if the failure is related to movement. In other words, if the flickering happens when you physically move the laptop. So this is a definite hardware failure that's most likely related to a bad LCD or inverter. Problems with keys sticking is another issue that can happen with laptops. One thing you notice is that laptop keyboards are not as durable as desktop keyboards, so they are more susceptible to wear and tear, so they tend to wear out a lot faster. So if you're going to repair or replace a keyboard on the laptop, you need to be extra careful. Another issue on laptops is sometimes people complain as they're typing on the keyboard that the mouse cursor will move all by itself. And this is known as ghost cursor. And the main reason that this happens, especially in my own personal experience and dealing with customers, is that when a person types on a laptop keyboard, a lot of times they don't realize that the palms of their hand, or maybe the sleeve on their shirt, is touching the touchpad, which will move the cursor. And so the best way to solve this issue is to go to the software touchpad settings on the computer and disable the tap feature. Or another issue that could cause this problem could be improper touchpad drivers. So the best thing to do in this case is to go to the manufacturer's website and download the correct and latest drivers for the touchpad. A very common issue that happens with laptops is overheating. A lot of people complain that as they're working on their laptop, the laptop shuts down or freezes, which is a very common symptom of overheating. Now, laptops have air vents either on the side or on the bottom of the laptop along with fans. And air passes through these vents and fans to help cool the laptop. But if these vents are blocked, for example with dust, or if the fans are dusty, it will hinder the laptop's cooling ability. So the best way to fix this is to get a can of compressed air and blow out the vents and fans and free them from any dust or debris. But another issue that causes a laptop to overheat is that a lot of times people use their laptops and they're not placing them on a hard flat surface. For example, they're using them on the couch or on their bed. And when this happens, a lot of times the vents and fans will get blocked and will hinder air circulation, especially if the fans and vents are on the bottom of the laptop. All laptops have the capability of wireless networking, and a lot of times you may experience a situation where you have an intermittent wireless connection. Now, this could be caused by a problem where there is interference between your laptop and your wireless router. Or it could also be that you're out of range of the wireless signal from your wireless router. Another issue could be that you need to update your wireless network card drivers, especially when there's a new operating system that's been released. In fact, I have personally found this issue to be very common with the release of a new operating system, especially with Windows 10, where a common fix to fix an intermittent wireless issue is to go to the laptop's manufacturer's website and update your wireless network card drivers. The power supply is the device that supplies power to the computer. It's a square metal box with a bunch of wires emerging from one end. It fits inside the computer case and is usually located at the very top or the bottom of a standard tower case. The power supply converts 110-volt AC current into the specific voltages that the computer needs. The most common form factor that a power supply comes in is ATX. The power supply is equipped with different types of connectors. One connector is called the P1 connector. This is the main power connector that connects directly into the motherboard and provides it with power. The P1 connector has either 20 or 24 pins. Another type of connector is called the P4. This is a 4-pin connector that also connects into the motherboard, and its purpose is to supply power to the CPU. This connector is used with modern motherboards. Another connector is called Molex. The Molex connector is a 4-pin connector that connects disk drives such as hard drives and CD and DVD-ROM drives. There is also a serial ATA connector. This is a 15-pin connector, and this is used to connect disk drives that have a serial ATA power plug. Another connector is called the 4-pin Berg connector, or mini connector. This is a small connector that is used to supply power to the floppy drive. And finally, there is the 6-pin connector. And this is used to supply power to certain PCIe video cards. The motherboard is the main component of a computer. It's basically a large circuit board where all the computer components connect to, such as the processor socket. The processor socket is where the CPU, or central processing unit, is placed. There's also the memory slots, and this is where the primary memory modules, known as RAM, are inserted. And there's also the bus slots. The bus slots are used to install various components to add more capabilities to a computer, such as a video card, sound card, network card, and so on. Motherboards come in different shapes and sizes, known as a form factor. The most common form factor motherboard that is used in PCs today is ATX. ATX stands for Advanced Technology Extended. It was created in 1995 by Intel and is now the de facto standard form factor for PCs today. A full-size ATX motherboard is 12 inches by 9.6 inches. Prior to the development of ATX was the AT form factor. AT stands for Advanced Technology. This was the form factor that was used in the 1980s that was developed by IBM. AT motherboards are 12 inches by 13.8 inches in size, and they are no longer in development since the succession of ATX. Another version of the ATX motherboard is the Micro ATX. Micro ATX motherboards are smaller than ATX boards, as its name suggests. Micro ATX boards are 9.6 inches by 9.6 inches, so it's a square design compared to the standard rectangular design of the ATX. They are cheaper than ATX boards and were designed to fit in smaller computer cases. They also have fewer features and consume less power than a standard ATX board. The BTX form factor was designed by Intel to make further improvements from the ATX form factor, such as an improved board design, which creates a more inline airflow, which improves cooling. For example, notice how the memory and bus slots are horizontal, flowing with the direction of the airflow instead of inhibiting compared to the ATX form factor. Another improvement is the structure design, which is flexible enough to work in both smaller cases and larger tower cases. And BTX motherboards take full advantage of the new input-output technologies such as serial ATA, USB 2.0, and PCI Express. Even smaller than the Micro ATX and BTX motherboards, there's the ITX form factor. The ITX form factor came out in 2001, starting with the Mini ITX shown here. And this was designed for the ever-increasing demand for smaller space-saving computers. The ITX standard consumes less power, and because they use less power, they are often cooled only by the use of heat sinks, and not with fans. ITX was developed by VIA Technologies, and there are currently 4 sizes that are in the ITX form factor. There's the Mini ITX. There's also the Nano ITX, which came out in 2005 and was designed to be used in devices such as digital video recorders, media centers, and cars. Then there's also the Pico ITX, which came out in 2007. And in 2009, VIA Technologies introduced the smallest x86 CPU module specification in the industry, with the release of the Mobile ITX. The Mobile ITX measures 6 centimeters by 6 centimeters, and it was designed to provide developers with a standardized and ultra-compact specification for building new computer-based products. Another form factor is the NLX. NLX was created by Intel, and it was designed for low-end, low-profile computers. Instead of expansion cards that plug perpendicular into the motherboard, the NLX boards use a riser card, where expansion cards can plug in parallel with the motherboard. You would typically find NLX boards in slimline computer cases. Motherboards come built with several input-output interfaces. These interfaces are largely located on the rear input-output panel of the motherboard. For example, the PS2 connector. The PS2 connector is a 6-pin multi-DIN connector. A motherboard will typically have 2 of these, and are usually located towards the top of the motherboard. One connector is for plugging in the mouse. This is the green PS2 slot. And the other is for plugging in the keyboard, which is the purple slot. But PS2 connectors are an older technology and is slowly being phased out in favor of the USB port. The most common interface on a motherboard is the USB port. USB stands for Universal Serial Bus, and motherboards will typically have several USB ports because there are so many different peripherals that utilize the USB interface, such as keyboards, mice, cameras, external drives, and printers. In addition to connectivity, the USB port also supplies electric power to that specific peripheral. Some USB ports are mounted on the rear input-output panel, and some are located directly on the surface of the motherboard. The first USB interface was version 1.0 in 1996. The transfer speed was 1.5 megabits per second. Version 1.1 was introduced in 1998 with a transfer speed of 12 megabits per second. Version 2.0 came out in 2001 with a transfer speed of 480 megabits per second. And the latest version is USB 3.0. This has data transfer speeds of up to 5 gigabits per second. Another interface that can be found in older motherboards is the serial port. The term serial refers to sending data 1 bit at a time. The serial port is an older technology interface which is rarely seen on new motherboards today. Back then, this was mainly used for connecting terminals and modems to computers. But now it has been widely replaced by the faster USB interface. The most common interface of a serial port is the RS-232 standard, which uses the common D connector, such as the DE9. The parallel port is another interface that could be found on a motherboard I/O panel. It was mainly used for connecting printers, and like the serial port, it is also being phased out and replaced by the faster performance of a USB port. It uses a wide D-sub connector known as the DB25. And unlike serial ports that send data 1 bit at a time, the parallel port sends data signals simultaneously over several parallel channels. A video adapter is another interface that could appear on the motherboard. Now I say it could appear because some motherboards have a video adapter and some don't. But the motherboards that do have a video adapter, then this is known as integrated video, because the video adapter and the motherboard are essentially one unit. The video adapter is what generates images from your computer to your monitor. The most common kind of port on an integrated video adapter is VGA, which stands for Video Graphics Array. The VGA port carries analog data, it has 15 pins, divided into 3 rows, and usually has a blue color. Integrated video adapters are usually not very powerful. They are good for normal everyday use with light applications, but when used for extensive graphic applications, such as gaming, they can fall short. That's why a lot of people will bypass the integrated video and buy an aftermarket video card that has enough power to suit their needs. The IEEE 1394 connector is commonly known as Firewire. Firewire is recognized by its D shape and is commonly used to attach devices such as digital cameras and printers. It's very similar to a USB port. Firewire and USB are both used to attach peripherals, and they both have similar transfer speeds. But Firewire is not as popular as USB. That's why on a modern motherboard today, there might not be any Firewire ports. Or if there are, you might find one or two. And Firewire has a transfer speed of 400 megabits per second. The NIC or Network Interface Card is a port on the motherboard that is used for networking purposes, such as connecting to the internet and sharing data between computers. The port is designed for an Ethernet cable with an attached RJ45 connector. A NIC provides a computer with a constant dedicated connection to a network. And each NIC has its own unique identifier called a MAC address. The transfer speed ranges from 10 to 1000 megabits per second. A sound card is another type of interface that could be found on a motherboard. And just like integrated video, if a motherboard has a sound card built in, then this is known as integrated sound. A sound card is what processes audio through the computer's speakers. A basic sound card has an audio output port for attaching speakers, and an input port for a microphone for recording purposes. More sophisticated sound cards will have extra ports. For example, ports for subwoofers and surround sound, and ports for other digital audio equipment. Some motherboards have a SATA port on the rear input-output panel. This is known as eSATA or external SATA. eSATA is for attaching an external SATA drive to a computer. For example, an external SATA hard drive. It functions similar to USB and Firewire, but the transfer speed is faster. But the disadvantage it has compared to USB and Firewire is that eSATA requires a separate power plug to supply the drive with power. But there is a new SATA port called eSATA P, which is power over eSATA. This port combines data transfer and power in an all-in-one port, similar to USB and Firewire. Adapter cards or expansion cards are circuit boards that can be installed into the expansion slots on a computer's motherboard. These adapter cards are installed to increase the functionality of the computer. Some examples of expansion cards are video cards, audio cards, storage cards, and so on. One of the most common adapter cards is a video card. A video card is what generates images from your computer to your monitor. A typical video card is a printed circuit board that directly attaches to the computer's motherboard. Video cards are also known as graphics cards, graphics adapters, and so on. A video card has several key components, such as a graphics processor unit or GPU, memory chips, a bus type, and video ports. The way video is transferred from the video card to the monitor is through the video ports. There are several different types of video ports that are used today. One port is called S-video or separate video, or also known as super video. S-video is an analog transmitter. It transmits two signals over one cable. One signal is for color, and the other signal is for brightness. The S-video port is round and is usually a black color. Another port is called VGA. This stands for Video Graphics Array. The VGA port is an older technology that was developed in 1987. The VGA port has 15 pins divided into 3 rows and usually has a blue color. The VGA port carries analog data. Another video port is called the Digital Visual Interface, or DVI. And this is a newer technology designed to succeed the older VGA port. It was developed in 1999, and it was designed to provide uncompressed, high-quality video to LCD monitors. Now, there are 3 different versions of the DVI cable standards. There's DVI-A, where the A stands for analog, and this is used to send only analog signals. And there's also DVI-D, where the D stands for digital, and this is used to send only digital signals. And there's also the DVI-I, where the I stands for integrated, and this is used to send both analog and digital signals. Now, on the connectors that are able to send digital signals, which would be the DVI-D and the DVI-I, there are 2 different options in the DVI standard. There's single link and dual link. The difference is that dual link has 6 extra pins, and these pins is what allows for a higher resolution than single link cables. Another type of video port is called HDMI, which stands for High Definition Multimedia Interface. HDMI was developed in 2002, and it was designed for transmitting uncompressed video and audio digital data through a single cable. HDMI is one of the best standards for high definition in consumer electronics, delivering crystal clear video as well as audio. And then there's also the display port. The display port debuted in 2006, and it was developed by VESA, which stands for the Video Electronics Standard Association. The display port was primarily designed to be used for video, but in addition to video, it can also be used to carry USB and audio data as well. It's a high-performance interface that is meant to replace the older VGA and DVI interfaces. And it can also connect using adapters to the older DVI, VGA, and HDMI ports. A sound card is another type of adapter card that processes audio through the computer's speakers. A sound card attaches into the computer's motherboard through a bus slot. A basic sound card has an audio output port for attaching speakers and an input port for a microphone for recording purposes. More sophisticated sound cards have extra ports. For example, ports for subwoofers and surround sound, and ports for other digital audio equipment. Other adapter cards include input-output cards. These include FireWire and USB cards. A FireWire card is an input-output card with a FireWire port. So if a computer doesn't have any FireWire ports, or if you wanted to add extra FireWire ports to your computer, you can insert this card into your computer's motherboard and add FireWire capability. Another input-output card is a USB card. Like FireWire, this is used to add extra USB ports to a computer. Now, since the USB port is so popular, and a lot of peripherals are made to use the USB port, usually a computer will have enough USB ports to suit a typical user's needs. But if you're the kind of user that needs more, you can insert a USB card to add more USB ports. There are also adapter cards for storage. For example, a RAID card. You can install a RAID card on a computer and implement a hardware RAID array for data redundancy. It's important to note that in a hardware RAID setup using a RAID card, the operating system is not aware of a RAID implementation. The RAID configuration is done strictly through the RAID card. We'll talk about RAID in an upcoming lesson. And there is also eSATA cards or external SATA cards. This card is used for adding external SATA ports to a computer, so you can add external SATA hard drives, which is mainly used for backing up and storing data. Some people have video capture cards installed on their computer, and these cards allow a user to capture analog video, for example, let's say from a video camera, and then convert it to a digital form and then store it on their computer's internal storage, such as a hard drive. And TV tuner cards allow signals from a television to be picked up by a computer, so you can not only watch TV from your computer, but you can also record TV programs and then store them digitally in your computer. In fact, a lot of TV tuner cards also act as a video capture card. Another type of adapter card is a network interface card, or NIC, and this is used to connect a computer to a network by using an Ethernet cable. It's basically a circuit board with a network adapter that is installed on your computer, and its job is to convert serial data into parallel data so the computer can understand it. A NIC provides a computer with a constant dedicated connection to a network. And each network card has its own unique identifier, called a MAC address. A wireless network card does the same thing that a wired card does, except that a wireless card does not use a cable to connect to a network. Instead, it uses a wireless connection. It has a built-in antenna that is used to wirelessly connect to a network to send and receive data. Now this is very convenient for computers that can be placed anywhere in different locations in a home or office without the hassle of messing with cables. Some laptops have an external slot that is used for inserting a PC card. A PC card is an expansion card for laptop computers. It was originally called a PCM-CIA card, which stands for Personal Computer Memory Card International Association, which is the form factor of a peripheral interface designed for laptop computers. The PC card just slides into the external slot, giving the laptop computer added capability, such as a Wi-Fi card, a network card, or a modem card. RAM, or random access memory, is temporary memory, and it's installed on the motherboard in the memory slots. A motherboard can have a various number of memory slots. The average motherboard will have between 2 and 4 of them. Memory slots come in different types, depending upon what type of RAM it accepts. For example, most motherboards have DIMM memory modules because it's the most common type to date. DIMM stands for Dual Inline Memory Module. A DIMM memory module has either 168, 184, or 240 pins. A DIMM is a dual inline module because it has 2 independent rows of these pins, one on each side. And DIMMs have a 64-bit data path. Another type of memory module is a SIMM. SIMM stands for Single Inline Memory Module. A SIMM is an older technology and has since been replaced by the much faster DIMM. A SIMM also has pins on both sides like a DIMM, but in a SIMM, the pins are redundant, compared to a DIMM, which are independent. A SIMM will either have 32 or 72 pins, and a 32-bit data path. Another type of memory module is called RAM, which stands for Rambus Inline Memory Module, which was developed by the company Rambus Inc. RIMs have 184 pins and look similar to a DIMM, with the exception that the bottom notches are located in the center of the module. In 1999, RIMs were a breakthrough in the speed of memory, but has quickly fallen behind due to the advancement of technology in DIMMs. Now the term 32 or 64-bit data path refers to the number of bits of data that are transferred in one cycle. The more bits that are transferred in one cycle, then the faster the computer will be. A single bit or 1 bit of data is the smallest form of data that the computer reads, because in the computing world, a computer only understands ones and zeros, which is represented by a single bit of data. Now there's also the term byte, and 8 bits is equal to 1 byte. So if a memory DIMM is rated to have a 64-bit data path, then that means that it has an 8-byte wide data path or bus, because 64 divided by 8 equals 8. And if a memory SIM that is rated to have a 32-bit data path, then that means that it has a 4-byte wide bus, because 32 divided by 8 equals 4. So that's why DIMMs are faster than SIMs. Now this information will be useful in an upcoming lesson on how we determine the exact bandwidth of memory modules. Cooling is very important to a computer. Computers generate a lot of heat, and if the components of the computer are not adequately cooled, the computer will overheat. And if it overheats, the computer will either run slow, lock up, or shut down, and will eventually shorten the life of the computer, because heat is an enemy to a computer's longevity. Two of the biggest heat generators come from the CPU and the video card. So the main way to adequately cool the computer is with case fans. Case fans are mounted inside the computer case. A basic case fan setup will include at least 2 fans. One fan that is mounted in the front of the computer is the intake fan. The intake fan is for drawing in cool air from outside the case to inside the case. The other fan is the exhaust fan, which is located in the back of the case, and it's designed to push air outside the case. And once these fans are in place, they're designed to work with each other to create a constant flow of cool air coming into and outside the computer to cool the computer components. So the cool air comes in, cools the computer components, and as the air makes contact with the hot components, the air naturally gets warmer and is then drawn outside the case. And then the cycle starts all over again to create a constant circulation. And this type of cooling is known as active cooling. The biggest heat generator in a computer is the CPU. As stated before, the CPU is the brain of the computer, and it produces an enormous amount of heat in a very short amount of time. In fact, if a CPU were to run by itself, without any extra cooling components, the CPU will likely fry itself within 10 seconds. So to remedy this problem, a CPU needs a heat sink to help dissipate the heat. A heat sink is basically an aluminum block with fins that directly makes contact with the CPU, and its purpose is to increase the surface area of the CPU so that it can make more air contact for cooling. The larger the heatsink, the larger the surface area will be, thus increasing the cooling ability. The fins on a heatsink are designed to further increase the surface area for air circulation. Once the heatsink makes contact, the heat will transfer from the CPU where the air can cool the heatsink, which will cool the CPU. And this type of cooling is known as passive cooling. It's important that the heatsink and CPU make the most contact with each other so that adequate cooling can take place. So that's why it's important to apply thermal compound on the CPU before attaching the heatsink. Thermal compound is used to fill in the microscopic air gaps between the heatsink and the CPU to make up for the imperfections of the flat surfaces. The surface areas between the CPU and the heatsink are flat, but they are not perfectly flat when examined with a microscope. The thermal compound is designed to fill in these gaps so that the most contact can be made between the two. A newer type of cooling is water cooling. Instead of using air, this type of cooling uses water to cool the computer components. For example, here is a water cooling unit for the CPU. There is a pump, hosing, and a radiator. And inside this unit is water. The unit is placed directly on top of the CPU, just like a traditional heatsink. And the pump inside constantly circulates the water throughout the entire unit to keep the CPU cool. Once the water reaches the radiator, the water is air-cooled by a radiator-mounted fan that draws air into the radiator and cools the water. This cycle is repeated so a constant flow of cool water makes contact with the CPU. And the end result is that water cooling units cool components far better than air cooling. And they are much quieter. But at the same time, water coolers are more expensive. In Section 1, we talked about secondary memory, which is permanent storage. This dealt with hard drives. Now we'll talk about primary memory, or temporary storage. This is called RAM. RAM stands for Random Access Memory. In order for data or a program to run, it needs to be loaded into RAM first. So here is how it works. The data or program is stored on the hard drive. Then from the hard drive, it is loaded into RAM. And once it's loaded into RAM, the CPU can now access the data or run the program. Now, a lot of times, if the memory is too low, it might not be able to hold all the data that the CPU needs. And when this happens, then some of the data has to be kept on the hard drive to compensate for low memory. So instead of data going from RAM to the CPU, it has to do extra work by going back to the hard drive. And when this happens, it slows down the computer. So to solve this problem, all you need to do is increase the amount of RAM on the computer. And by increasing the memory, all the data can be loaded into RAM without the need of constantly accessing the hard drive. And the result is a faster performing computer. RAM requires constant electrical power to store data. And if the power is turned off, then the data is erased. RAM is stored on the motherboard in modules that are called DIMMs. And these DIMMs come in different memory sizes. Today, they range anywhere from 128 megs up to 64 gigabytes of memory per DIMM. RAM also comes in different types, such as dynamic RAM or DRAM. DRAM is memory that contains capacitors, and because it has capacitors, it has to be refreshed often. SRAM stands for static RAM. This memory uses transistors and does not have to be refreshed, unlike DRAM. And because of this, it is much faster than DRAM, and it is also very expensive. An example of SRAM would be the memory cache level 1 and 2 that is used by the CPU. Another type of memory is called SDRAM, which stands for synchronous DRAM. This type of memory is what is used today in RAM DIMMs. The difference between SDRAM and DRAM is basically speed. The older DRAM technology operates asynchronously with the system clock, which basically means that it runs slower than the system clock because its signals are not coordinated with it. But SDRAM runs in sync with the system clock, which is why it is faster than DRAM. All the signals are tied to the system clock for a better controlled timing. SDRAM is rated at different speeds. For example, a stick of SDRAM could be labeled PC100. The 100 equals the speed at which it operates, which is 100 MHz. And since SDRAM only comes in 64-bit modules, it has an 8-byte wide bus, because 64 divided by 8 equals 8. So to figure out the total bandwidth of PC100, you multiply 100 MHz times 8 bytes, which equals 800 megabytes per second. So the total bandwidth of PC100 equals 800 megabytes per second. So an SDRAM module labeled PC133, you multiply 133 by 8 bytes, which equals 1066. So the total bandwidth for PC133 equals 1066 megabytes per second. As technology increased and processor and bus speeds have gotten faster, a new RAM technology was developed to keep up with the faster speeds of computers. This newer technology was called DDR, which stands for double data rate. And that's basically what DDR does. It sends double the amount of data in each clock signal when compared to non-DDR RAM. Non-DDR or single data rate RAM uses only the rising edge of the signal to transfer data. But DDR uses both the rising and falling edges of the clock signal to send data, which makes DDR twice as fast. DDR is also labeled differently than non-DDR RAM. Instead of including the clock speed in its name, like PC133, where 133 equals the clock speed, DDR uses the total bandwidth instead. For example, a DDR DIMM labeled PC2700, the 2700 is not the clock speed, but it's the actual total bandwidth. The clock speed for PC2700 is 333 MHz. So 333 MHz times 8 bytes is rounded off to 2700 megabytes per second, which is where we get the name PC2700. Another example is PC3200. PC3200 has a clock speed of 400 MHz. So 400 times 8 equals 3200, which is where we get the name PC3200. A new technology that has succeeded DDR is DDR2. DDR2 is faster than DDR because it allows for higher bus speeds, and it also uses less power than DDR. A DDR2 DIMM has 240 pins, compared to 184 pins on DDR. Some examples of DDR2 are PC2 3200 and PC2 4200. And the latest RAM technology is called DDR3. DDR3 is twice as fast as DDR2, with a bandwidth of over 12,800 megabytes per second. Like DDR2, a DDR3 DIMM also has 240 pins, but the notches in the DIMMs are in different places. So you can't put a DDR3 DIMM in a RAM slot made for DDR2. In fact, motherboards are made to support a certain type of memory, so you can't mix DDR1, 2, or 3 on the same motherboard. Some examples of DDR3 are PC3 8500 and PC3 12800. Another type of memory was called RDRAM, which was developed by Rambus Inc. And they developed the RIM, which stands for Rambus Inline Memory Module. RIMs have 184 pins, and look similar to DIMMs, with the exception that the bottom notches are located in the center of the module. In 1999, RIMs were a breakthrough in the speed of memory, but has quickly fallen behind due to the advancement of technology in DIMMs. When RDRAM debuted in 1999, it ran at 800 MHz, which was considerably faster than SDRAM, which ran at 133 MHz at that time. But even though it was a lot faster than SDRAM, RDRAM only had a 2-byte wide bus, compared to SDRAM, which had an 8-byte wide bus. So if you multiply the speed of RDRAM, which was 800 MHz, times the bus width, which was 2 bytes, you will get a total bandwidth of 1600 megabytes per second. RIM technology was designed to work with a continuous signal, which means that all the other memory slots on the motherboard must be used for RIMs to work properly. And if other RIMs are not available, then a user can install a CRIM or continuity RIM, which is basically a dummy RIM to ensure continuity in all the memory slots. To meet the higher demands of faster processors and memory controllers, a new technology was developed called dual-channel mode. Dual-channel mode requires a pair of identical DIMMs installed on the motherboard, which allows the memory controller the ability to communicate with 2 DIMMs simultaneously, which increases the speed of accessing the memory. In order for dual channel to work, the motherboard must be equipped to work in dual channel mode, and the memory DIMMs must be identical to each other in speed, size, and features. Then the DIMMs must be inserted into the motherboard in a specific slot configuration in order to enable dual-channel mode. Typically, the memory slots will be color-coded to help assist in identifying where the DIMMs should be inserted. For example, here we have some dual-channel memory slots. So in order for dual-channel to work, you need to install a pair of identical DIMMs in the slots of the same color. In this case, we put a pair of DIMMs in the yellow slots. And there is also triple channel mode. Triple channel mode is not very common, and very few motherboards offer this feature. Triple channel mode allows the memory controller the ability to communicate with 3 DIMMs at the same time. In modern computers, motherboards have a 64-bit architecture. So in single channel mode, it can transfer 64 bits of data at a time. In dual channel mode, that is doubled to 128 bits at a time. And in triple channel mode, it's tripled to 192 bits at a time. So as stated before, triple channel mode is only available on a few motherboards, and only certain Intel Core i7 processors support triple channel mode. So here is an example of a triple channel capable motherboard. On this motherboard there are 6 memory slots with 2 different colors. So if you're going to install 3 DIMMs on this motherboard, you must put the DIMMs in the same color-coded slots in order to utilize triple channel mode. And those DIMMs must be identical. Now the term single-sided or double-sided RAM doesn't necessarily refer to the physical location of the memory chips that are on the sides of the memory module, but it refers to the groups of memory chips that a memory controller accesses. So for example, double-sided RAM has 2 groups of memory chips. Now this doesn't mean that the memory chips are physically located on both sides of the memory module. Now they can be on both sides, or they can be on just one side, but that's not what double-sided means. It means that the memory controller sees these 2 groups of memory chips separately, and it can only access them one group at a time. Now single-sided RAM has one group of memory chips. Now these chips can be physically either on one side or on both sides of the memory module. But that's not the point. The point is that because it's single-sided RAM, the memory controller can access it as one group. And because it's one-sided or one group, the memory controller can access it as one group, which makes single-sided RAM faster than double-sided RAM. Some RAM modules have ECC, which stands for Error Correcting Code. And what this does is that it detects if the data was correctly processed by the memory module, and makes a correction if it needs to. You can tell if a RAM module has ECC by counting the number of memory chips on the module. In a standard non-ECC DIMM, it will have 8 memory chips. But in an ECC module, it will have 9 memory chips. Most RAM modules today are non-ECC, and this is because of the advance in technology that has minimized memory errors and has made non-ECC RAM more stable. Typically today, ECC memory is mostly used in servers because servers need to be up and running at all times, and using ECC memory is just an extra precaution to guard against any memory errors. And there is also buffered and unbuffered RAM. Now buffered RAM, which is also called registered RAM, is made to add stability to RAM. Buffered RAM adds an extra register between the RAM and the memory controller. It stores data or buffers data before it gets sent to the CPU. And this is what adds stability and reliability in computer systems that have a lot of memory modules installed. So it's basically used to lessen the electrical load on your memory controller that's produced when you use a lot of memory modules. For example, in servers. The kind of RAM that is used in smaller devices, such as laptops, is called SODIMM. SODIMM stands for Small Outline Dual Inline Memory Module. SODIMMs are roughly half the size of regular DIMMs. And like DIMMs that are used in desktops, SODIMMs also come in different types, such as DDR, DDR2, and DDR3. So if you plan on adding RAM to your laptop, you need to make sure you install the correct type, because the different levels of DDR in the SODIMMs are not compatible with each other. The processor socket is the place on the motherboard where the CPU is placed. The socket is a square plastic or metal holder with multiple holes to accommodate the pins on the bottom of the processor. As these holes and pins make contact, they provide physical and electrical contact between the motherboard and the CPU. Modern CPU sockets are called ZIFs, which stands for Zero Insertion Force, which basically means that the CPU is installed in the socket with no force. It just drops in the socket easily. There are different types of CPU socket designs called packages. One of the most common types of these packages is the PGA, or Pin Grid Array. The PGA package is a typical square ZIF socket design with holes and a lockdown lever. The latest in socket design packages is called LGA, which stands for Land Grid Array. The LGA socket is a metal casing with a door that closes over the CPU and locks down with a lever. Unlike previous socket versions, which have holes, the LGA has pins that make contact with the bottom of the processor. LGA processors don't have pins. Instead, they have pads that rest on the LGA socket pins. For the CompTIA A+ exam, you're going to need to know a few characteristics about certain socket types. And these socket types are categorized by 2 different brands. There is Intel and there's AMD. So starting with the Intel sockets, which use the LGA package, the first one that we're going to talk about is the LGA 775 socket. And this is also known as socket T. It was released in 2004, and it has 775 pins, as its name states. The LGA 775 was the successor to the socket 478, and it was designed for the Pentium 4 and Pentium dual-core processors. And next is the LGA 1366, and as its name states, this has 1366 pins. And this was also known as socket B. It was released back in 2008 and has succeeded the LGA 775. The LGA 1366 uses the Intel Core i7 and Xeon processors. The LGA 1156, which is also known as socket H or socket H1, was released in 2009, and this has 1156 pins, and this was the first socket to be used by the Intel Core i3 and i5 processors. And next is the LGA 1155, and this is known as socket H2, and this was designed to replace the LGA 1156. And this has 1155 pins, which is one less than the LGA 1156. But the CPUs that are designed for the 1155 and 1156 are not compatible because the notches in the sockets are different. It was released in 2011, and these were designed for the Intel CPUs that use the Sandy Bridge and Ivy Bridge architecture. And next is the LGA 1150, and this is also known as socket H3, and this has 1150 pins and was released in 2013. The LGA 1150 supports Haswell and Broadwell based microprocessors and has succeeded the LGA 1155. And the last of the Intel sockets is the LGA 2011, which is also known as socket R. The LGA 2011 has 2011 pins and was released in 2011 and has succeeded the LGA 1366. And this socket was designed for high-performance CPUs that are based on the Sandy Bridge and Ivy Bridge processors. So the next group of sockets are the AMD sockets, which utilize the PGA package. And the first socket is the AM3. Socket AM3 was released in 2009 and is a successor to the AM2 Plus socket. The AM3 has 941 pins. Next is socket AM3 Plus, which is the successor and a modification of the AM3. It has 942 pins and was released in 2011. The AM3 Plus does retain compatibility with AM3, so CPUs designed for the AM3 Plus will work in AM3 sockets. The next socket is FM1, and this was released in 2011, and it has 905 pins. And these were designed for the AMD APU processors. APU stands for Accelerated Processing Unit. And these were designed to act as a CPU and a graphics accelerator on a single chip. And next is FM2, and this has 904 pins and was released in 2012. And then last is the FM2 Plus, and this was released in 2014, and this has 906 pins, and this was a new revision of the FM2 socket. The Central Processing Unit, or CPU, is the main component on the motherboard. It's the brain of the computer where all the data processing takes place. It's in charge of executing program instructions and logical calculations. The CPU is the largest component on the motherboard. It's a square chip that is inserted into the motherboard in a plastic or metal holder called a CPU socket. And directly on top of a CPU is the heatsink and fan, and these are used to keep the CPU from overheating. The speed of the CPU is measured in megahertz. For example, 1 megahertz equals 1 million cycles per second. 500 megahertz equals 500 million cycles per second. And 1 gigahertz equals 1 billion cycles per second, and so on. Today's high-end processors average a speed of over 3 gigahertz per second. Inside the processor is the core. The core is where the reading and execution of instructions take place. A processor that has a single core processes instructions one at a time. But today's higher-end processors have more than one core. These are called multi-core processors, and they can process more instructions than a single-core processor, which gives a multi-core the ability to multitask and have a greater overall performance. Some examples of a multi-core processor are dual-core processors, which has 2 cores. Another example is a quad-core processor, which has 4 cores. Two of the biggest manufacturers of processors are Intel and AMD. Intel, being the largest manufacturer of processors, was founded in the late 60s and has since dominated the CPU market for a number of years until the rise of AMD started to become its chief competitor. Some of the Intel processors are known as the 286, 386, 486, Celeron, and Pentium processors. Advanced Micro Devices, or AMD, is the second largest manufacturer of processors. AMD was also founded in the late 60s, but it didn't really start to compete with Intel in the CPU market until the mid-1990s. Some of the AMD processors are known as the K5, K6, Athlon, Duron, and the Sempron processors. Their higher-end processors include the Athlon 64, Opteron, and Phenom. CPUs can come in 32 or 64-bit versions. The difference between a 32-bit and a 64-bit is the way that it handles memory. The bit size of the CPU refers to the memory it can address. A 32-bit CPU can reference 2 to the 32nd power bytes of memory, which equals about 4 gigabytes. However, a 64-bit CPU can reference 2 to the 64th power bytes of memory, which equals to about 16 exabytes, which is 4 billion times more memory than a 32-bit. Now that number is so huge that it's virtually unlimited, because we will never need to use that amount of memory. So going back to what we stated before, in order for data or a program to run, it needs to be loaded into RAM first. So the data is stored on the hard drive, then from the hard drive it is loaded into RAM. And once it's loaded into RAM, the CPU can now access the data or run the program. Now in a 32-bit system, since the maximum amount of memory it can support is 4 gigabytes, it may not be enough to hold all the data that the CPU needs to make the computer run as fast as possible. And when this happens, then some of the data has to be kept on the hard drive to compensate for the low memory. So instead of data going from RAM to the CPU, it has to do extra work by going back to the slower hard drive. And when this happens, it slows down the computer. But in a 64-bit system, it's able to store a lot more memory than 4 gigabytes, which means that more data can be loaded into the faster RAM than on a slower hard drive. And because it can store more data on the faster RAM than on a slower hard drive, the computer is able to run a lot faster. So in a nutshell, this is why a 64-bit system is faster than a 32-bit system. There's also what's called memory cache. The memory cache is made of SRAM or static RAM, which is very fast memory when compared to regular DRAM that is used for primary memory. The memory cache is the processor's internal memory, and its job is to hold data and instructions waiting to be used by the processor. So basically what cache does is that it holds common data that it thinks the CPU is going to access over and over again. Because when the CPU needs to access certain data, it always checks the faster cache memory first to see if the data it needs is there. And if it's not, then the CPU will have to go back to the slower primary memory or RAM to find the data it needs. So that's why cache memory is so important, because if the CPU can access what it needs on the faster cache memory, then the faster the computer will perform. The memory cache comes in different levels. For example, there's level 1 cache, which is also called primary cache. Level 1 cache is located on the processor itself, so it runs at the same speed as the processor. So it's very fast and is the fastest cache memory on the computer. And there is also level 2 cache, which is also called external cache. And level 2 cache is used to catch recent data accesses from the processor that were not caught by the level 1 cache. So in a nutshell, if the CPU can't find the data it needs on the level 1 cache, it then searches the level 2 cache for the data. And if level 2 doesn't have it, then it has to go back to the regular RAM to find the data it needs. Level 2 cache is generally located on a separate chip on the motherboard, or in modern CPUs, it would also be located on the processor. Level 2 cache is larger than level 1 cache, but it's not as fast as level 1 cache. One of the main and one of the most important components you'll find on a motherboard is the chipset. Older motherboards were designed with a lot of different chips scattered all over the motherboard. There were chips for different things, like chips for bus controllers, memory controllers, keyboard controllers, and so on. So they had a lot of different chips controlling different functions on the motherboard. So as technology progressed, computer engineers decided to reduce the number of chips and have them more in a centralized location. So instead of having these different chips scattered all over the motherboard controlling different functions, they reduced the number of chips to do the same job and condensed them to only a few chips, or what's now called a chipset. And that's what a chipset is. A chipset is a smaller set of chips that has replaced a larger amount of chips. And the chipset's job is to control data flow between the CPU, the peripherals, bus slots, and memory. So all of the different parts of the computer communicate with the CPU through the chipset. The chipset basically consists of two chips. One is called the North Bridge, and the other is called the South Bridge. The North Bridge is located in the upper or northern part of the motherboard, providing you're looking at the motherboard in the upright position. It's located near the CPU and is directly connected to the CPU. It's also directly connected to the memory and the AGP and PCI Express slots. So in order for the CPU to communicate with the memory and the AGP or PCI Express bus, it has to go through the North Bridge first. So the North Bridge acts like a communication middleman between the CPU, AGP or PCI Express, and memory. The other chip is called the South Bridge, and the South Bridge is located at the bottom or southern portion of the motherboard, near the PCI bus slots. The south bridge connects to the PCI bus slots, SATA and IDE connectors, and USB ports. So the south bridge is responsible for the lower portion of the motherboard, while the north bridge is responsible for the upper portion. There is no direct connection between the CPU and the lower portion of the motherboard. So if the PCI, USB, IDE, or SATA ports needed to communicate with the CPU, the information has to go through the south bridge, and then up through the north bridge, and then to the CPU. The north bridge is faster than the south bridge, and that's because the CPU, the PCIe, AGP, and memory are the most used and most important components of the motherboard, so they need to operate at the highest speeds possible. The slower south bridge communicates with the PCI bus, SATA and IDE connectors, and USB ports, and they don't need to be as fast as the other components. So basically the higher speed components are connected to the north bridge, and the slower components are connected to the south bridge. Now both the north and south bridge make these connections to various parts of the motherboard using pathways called a bus. And a bus is simply a set of pathways that allows data and signals to travel between components on the motherboard. The motherboard contains several kinds of buses that vary in speed and bandwidth. So for example, if a bus speed is said to operate at 66 MHz, then that means that that particular bus can send data at 66 million cycles per second. The higher the bus speed, the faster the computer can send data, which improves the performance of the computer. A motherboard's bus speed generally refers to the speed of the front side bus. The front side bus is the connection between the CPU and the north bridge chipset. All motherboards are equipped with input-output bus slots. These are typically located on the bottom rear of the motherboard. These bus slots are also called expansion slots because these slots are used to expand the capability of the computer. For example, if the motherboard doesn't already have a built-in sound card, then you can add a sound card by inserting one into one of these bus slots, giving your computer the ability to produce sound. Or, let's say the motherboard doesn't have enough USB ports to suit your needs. Well, then you can add a USB expansion card in one of the bus slots to add more USB ports. A modern bus type today is called PCI, which stands for Peripheral Component Interconnect. PCI has been around since 1993 and was the standard bus slot for modern motherboards until PCI Express came out, which we'll talk about shortly. PCI slots are much faster compared to ISA slots, with a data path of 32 or 64 bits, with speeds ranging from 133 to 533 megabytes per second. They are also about half the physical size and length of the ISA slot. As computers got faster, a lot of people were using their computers for higher-end graphics applications such as gaming. And as computers became more graphically oriented, the PCI slot was lagging behind in delivering computer graphics data. For this purpose, the AGP slot was developed. AGP stands for Accelerated Graphics Port, and it was created to assist in accelerating 3D computer graphics. One of the main reasons why AGP is faster than PCI is because AGP has its own dedicated pathway to the processor, unlike PCI. The AGP port is only used for a video card and is usually a brown color. PCI Express is the latest version of bus slots. It's faster than its predecessor with speeds up to 4 gigabytes per second. And unlike standard PCI, which transfers data in parallel, PCI Express transfers data in serial. Transferring data in serial is much faster than parallel because serial data is transferred in packets. PCI Express was designed to succeed all other PCI bus slots and AGP. And it is not backward compatible with standard PCI because the architecture is very different. There are 4 different slot sizes in PCI Express. There's PCI Express by 1, 4, 8, and 16. PCIe by 1 has 1 lane for data. A lane has 4 wires. 2 are for sending and 2 are for receiving. PCIe by 4 has 4 lanes. PCIe by 8 has 8 lanes. And the fastest slot is PCIe by 16, which has 16 lanes. And PCIe by 16 has succeeded the AGP slot for the video card. And there is also the PCIx slot, where the X stands for extended. The PCIx slot is basically an extension of the old standard PCI slot, and it's almost twice the length of a standard PCI slot. The PCIx is a 64-bit bus, and it is backwards compatible with the standard PCI slot. It was mainly designed to work with servers and high-speed computers. And there is also the mini PCI slot, and this is what is used in laptops. It's approximately 1/4 the length of a standard PCI slot. The mini PCI slot is a subset of the standard PCI bus, but it's a lot smaller. Now you can insert a regular PCI card into a mini PCI slot, but you would have to use a mini PCI to PCI converter. The mini PCI is a 32-bit, 33 MHz bus. Typically located at the bottom right-hand corner of the motherboard, you'll find what's called the front panel connector. And this is where you would plug in wires that connect to items that are in the front bezel of the computer case. So for example, there is the power button connector, and this turns the computer on or off. There's also the power LED, which indicates when the computer is on or off or in standby mode. There is also the hard drive LED, which indicates when there is hard drive activity. And there is also the reset switch, which restarts the computer by doing a hard boot. And there's also a speaker connector, which is used to plug in the internal speaker of the computer. Now oftentimes the front panel connector will be color-coded, as you see here, and this is to help identify where the wires connect to, which makes knowing where to connect the wires a lot easier. Most computers today will have certain common connections on the front panel of the computer for easier access. For example, you may find some USB ports in the front, and you may find some audio ports, one for headphones or speakers, and another one for a microphone. And also on the front panel, you will see the power button, and this is for turning on and off the computer. And you will also see a reset button, and this is for doing a hard reboot. And also you will see a drive activity light. Now this light blinks when there is activity in the computer. In other words, when the hard drive is being accessed. BIOS stands for Basic Input Output System. The BIOS is software that is built into the motherboard that initializes the computer's peripherals as the computer is being booted. Some of these peripherals include the keyboard, mouse, video card, optical drives, and so on. And after it initializes the peripherals, it then searches for a boot device, like an optical drive or a hard drive, to boot software or to boot an operating system. The BIOS software is stored on the BIOS chip on the motherboard. The BIOS chip is non-volatile, which means that the software and settings are retained even after the power is turned off. On modern computers, the BIOS is stored on flash memory chips, which makes the BIOS capable of being updated using a special program. Some popular vendors of BIOS software are American Megatrends and Phoenix Technologies. After a computer is turned off, and if the power cable is unplugged, the computer needs to maintain certain settings, such as the date and time and hardware settings. And these settings are stored on the motherboard in a special chip called a CMOS chip. CMOS stands for Complementary Metallic Oxide Semiconductor. And in order for the CMOS chip to maintain these settings, it needs a battery. This battery is called the CMOS battery. The CMOS battery is a small button cell battery which can be seen on the surface of the motherboard and is usually located on the bottom right-hand corner. The CMOS battery is basically the same type that is typically used in wristwatches. When you turn on a computer, the computer does what's called a power-on self-test, or POST, that is run by the BIOS. It tests the computer to make sure all the requirements are met and the hardware is working correctly before continuing. And after POST is passed, the BIOS searches for something to boot from, such as an operating system, which is typically loaded on the hard drive. But the computer doesn't necessarily have to boot to an operating system. It can also boot from other things, such as a CD or DVD disc, floppy disk, or USB flash drive, just as long as those things have the necessary boot files on them. And how the BIOS determines which device to boot from depends on the boot order in the CMOS settings. And in the CMOS settings, you can make changes in the priority boot sequence. So for example, if the CD or DVD drive is set as the first boot device, then the BIOS would check that first and look for software to boot from. And if it doesn't find anything, it will move on to the second device on the list and check that next. And it will continue down the list until it finds something to boot from. But you can change the boot priority in CMOS in any order you choose. And once you make the change, you just save the settings, and the next time you reboot the computer, the settings will take effect. Now there are certain things you can do while you're in the BIOS. For example, you can set the date and time. The date and time should be accurate because the operating system does reference it. Other things you can do in the BIOS is enable or disable certain devices. For example, if your motherboard has a built-in video, network, or sound card, you can disable these devices in the BIOS to save resources if you're not using them. But you really only want to disable these if your motherboard already has the adapter cards installed on the motherboard that already give you these capabilities. The BIOS also allows you to modify the CPU clock speed by either increasing the clock speed to make the computer run faster, which as a result will increase the temperature, or by reducing the clock speed, which will make the computer run slower but will lower the temperature of the CPU. Now this could be especially useful if your computer is having overheating issues. And speaking of temperature, the BIOS can also monitor the temperature of the CPU. The BIOS has a built-in safety mechanism that if the CPU reaches a certain temperature threshold, it will automatically shut down the computer. Or if it detects that the CPU fan is not spinning, it'll also shut down the computer to prevent damage to the CPU from overheating. But these temperature thresholds can be modified in the BIOS if you want to, by either increasing or decreasing the temperature threshold. And in the BIOS, you can also modify the fan speeds of the computer. And you can also enable or disable virtualization in the BIOS. Virtualization is a technology that enables your computer to run multiple operating systems in different partitions. The operating systems are not actual, but they are virtual. So if your computer is preventing you from installing or running virtualization software, it could be that virtualization is disabled in the BIOS. One way to protect your computer from unauthorized users is by using password protection in the BIOS. Using a BIOS password not only prevents changes to the BIOS settings, but it also prevents the system from booting. A user cannot boot the computer or make any changes in the BIOS without the BIOS password. When you turn on a computer, the computer does what's called a power on self-test, or POST. It tests the computer to make sure all the requirements are met, and that the hardware is working correctly before starting the operating system. If the computer passes the test, the internal speaker will make a short single beep, which indicates that the computer has passed the test and is booting up normally. However, if there's no beep or if there are multiple beeps, then that means that the computer has failed the test and something is wrong, and the computer needs further troubleshooting to find out what the problem is. Now, whether there are no beeps or multiple beeps, the computer will generate this beep code to help you pinpoint the problem. For example, if the computer generates 3 long beeps, then that could indicate a keyboard error. Or if the computer generates a continuous short beep, then that could indicate a problem with a memory module. Whatever BIOS is installed on a computer's motherboard, you can always refer to the manufacturer's documentation to find a list of beep codes and what they mean. Some BIOS systems have an intrusion detection feature. Now, this feature detects if the computer case has been opened and alerts the user. And some computers, especially laptops, can be equipped with LoJack, which is a service that can locate your computer if it has been stolen. A newer type of BIOS is called UEFI. UEFI stands for Unified Extensible Firmware Interface. Now, most, if not all, new motherboards are shipped with this newer type of BIOS. UEFI has several advantages over the old BIOS, and the first and most obvious, just by looking at it, is that it has a user-friendly graphical user interface that supports different colors and even animations, whereas the old BIOS has your typical blue screen that resembles the Windows blue screen of death. UEFI can also recognize larger hard drives, and you can even use a mouse while you're in the UEFI interface as compared to the old BIOS where mouse support was not even available, and you had to use your keyboard only. And UEFI also has a built-in feature called Secure Boot, and Secure Boot stops any digitally unsigned drivers from loading, and it helps to stop malicious software such as rootkits. Storage is a very important part of fault tolerance. If something were to happen to a company's data, such as a disk failure, that results in data loss, then that could have a serious impact on how the company performs. That's why we need to make sure that if a disk does fail, that no data loss would occur. And one of the best ways to prevent data loss is RAID. RAID stands for Redundant Array of Independent Disks. In a RAID setup, the data is copied on multiple disks, so that in the event of a disk failure, no data would be lost. Now there are 4 common types of RAID. There is RAID 0, RAID 1, RAID 5, and RAID 10. Now RAID 0 is not fault tolerant. In fact, RAID 0 shouldn't even be called RAID, because not only does it not provide fault tolerance, it actually increases the chance for data loss. Because in a RAID 0, the data is not duplicated, but it's actually spread or striped across 2 separate disks. So if just one of these disks fails, then all the data would be lost. So the only reason why you would want to use RAID 0 is speed. Because when you have 2 disk controllers working instead of 1, then accessing data is much faster. Now RAID 1 is fault tolerant. In a RAID 1 setup, the data is copied on more than one disk. So disk 2 would have the exact same copy of the data as disk 1. So in the event of a single disk failure, then no data loss would happen, because the other disk would have a duplicate copy. Next, we'll talk about RAID 5. In order to use RAID 5, you need to have 3 or more disks. RAID 5 is probably the most common setup that is used, because it's fast and it can store a large amount of data. So in a RAID 5 setup, data is not duplicated, but it's striped or spread across multiple disks. And in addition to the data, there is another very important piece of information that is being evenly spread across all the disks. And this information is called parity. And parity is used to rebuild the data in the event of a disk failure. But there is a downside to RAID 5, because since the equivalent of an entire disk is used to store parity, it reduces the collective amount of data that can be stored in this array. So for example, if all 4 of these disks were 1 terabyte each, that totals 4 terabytes. But in a RAID 5 setup, the total amount that would be used for data storage would be 3 terabytes, because the equivalent of 1 entire disk would be used to store parity. Now we have to talk about RAID 10. And RAID 10 is basically what the name says. It's combining RAID 1 and RAID 0 together. And you need to use a minimum of 4 disks. So in a RAID 10 setup, a set of 2 disks are mirrored using a RAID 1 setup. Then both sets of the 2 disks are striped using RAID 0. So a RAID 10 setup benefits from the fault tolerance of RAID 1 and the speed of RAID 0. But the downside in a RAID 10 is that you can only use 50% of the capacity for your storage. So if you're using 4 disks in a RAID 10 setup, you can only use 2 of them for actual storage. Now this is the RJ11 connector, and RJ stands for register jack. And this is a 4-wire connector used mainly to connect telephone equipment. But as far as networking, the RJ11 is used to connect computers to local area networks through the computer's modem. The RJ11 locks itself into place by a hinged locking tab, and it resembles the RJ45, but it's a little bit smaller. Now the RJ45 is by far the most common network connector. This is an 8-wire connector used to connect computers to local area networks. And like the RJ11, it also locks itself into place by a hinged locking tab, and it also resembles the RJ11, but it's a little bit larger. The BNC connector is a common type of RF connector that is used on coaxial cable. BNC stands for Bayonet Neil Conselman, and it is used for both analog and digital video transmissions, as well as audio. Now this connector is called the F-type. Now this is a threaded connector typically used on coaxial cables. These are primarily used by cable providers to attach to cable modems. The F-type hand tightens by an attached nut. This is the IEEE 1394 connector, and this is also known as Firewire. Firewire is recognized by its D shape. This type of connection is becoming more popular on desktops and laptops, and is commonly associated with attaching peripheral devices such as digital cameras and printers rather than being used as network connections. These are also found on many types of video and multimedia devices. Now this is a USB connector. The USB is very common on desktops and laptops, and just about every kind of peripheral connects to a computer using the USB connection. There are also several different types of USB connectors. There's the Type A, Type B, the Mini USB, and the Micro USB. A newer type of interface for attaching external peripherals is called Thunderbolt. Thunderbolt is a high-speed technology interface that outputs one serial signal from a combination of PCI Express and the display port. Thunderbolt was released in 2011 and was mainly used in Apple products, and now have become available to PCs. There are 3 different versions of Thunderbolt. Versions 1 and 2 uses the same connector as a mini display port, and Type 3 uses a USB Type-C connector. Another type of connector is called RCA. The RCA is an older connector that was produced back in the 1940s, and these were primarily used to carry video and audio signals. A lot of times you may see RCA connectors in groups of 3, a yellow, a white, and a red, where the white and red are used for audio, such as a left and right speaker, and the yellow would be used for video. Our next fiber optic connector is called the ST, or straight tip. This uses a half-twist bayonet type of lock, and is commonly used with single-mode fiber optic cable. And our next connector is called the LC, or local connector. And this is also a fiber optic connector. It uses a jack similar to the RJ45. This type of connector is commonly used between floors in a building. And our last fiber optic connector is called the SC, or standard connector. And this uses a push-pull connector similar to audio and video plugs. And like the LC connector, this is also commonly used between floors in a building. The term plenum refers to a space in a building where there is open air flow circulation, and this is usually between the drop ceiling and the structure ceiling. Buildings that don't have plenum spaces have air ducts encapsulating the airflow. So as a result, buildings that have plenum spaces where there is adequate open air flow are more prone to fires than buildings that don't have plenum spaces. And because of this, cables that run through plenum spaces must meet certain requirements. First, they must be more fire resistant, and secondly, they must not produce any toxic fumes if they are burned. Sometimes there might be cases in your home or office where you wanted a certain computer in a certain part of the building to be able to access the internet or to be networked. And for whatever reason, network cabling or Wi-Fi just wasn't an option in that part of the building. Maybe because of difficulties in the structure of the building or interference or whatever. So another 1901 standard gave the ability to network using the existing electrical system of the building. Ethernet over power line gives this ability of Ethernet networking over power. So for example, let's say you needed this computer up here to be able to access the internet, but for some reason you can't get any network cables or any Wi-Fi signal to reach that computer. So in this case, we're going to use Ethernet over power. So we're going to need a couple of power line adapters like these. These power line adapters plug directly into a power outlet, and they have a built-in Ethernet port for an RJ45 connector. So one of them plugs into the power outlet next to this computer up here, and then you will connect an Ethernet cable from the network port of the computer and the other end into the power line adapter's Ethernet port. Then the other adapter plugs into the power outlet next to the modem or router down here. Then you would plug an Ethernet cable from the modem or router to the power line adapter. And now Ethernet data will use the building's electrical wiring to deliver networking data to the other power line adapter so that the other computer can access the internet. The terms 568A and 568B refer to a set of wiring standards developed by TIA/EIA, which is also known as the Telecommunications Industry Association. And these terms define the rules on how twisted pair cables should be wired to RJ45 connectors. And these wires must follow a certain order so that the network can function properly. The 568A standard is wired in this order: white-green, then green, white-orange, blue, white-blue, orange, white-brown, and brown. And the 568B standard is wired in the following order: white-orange, then orange, white-green, blue, white-blue, green, white-brown, and brown. There is no difference in the functionality as to which standard is used. Whether you choose to use the A or B wiring standard, if both ends of the cable are wired using the same standard, then this is known as a straight cable. For example, this cable is wired on both ends using the 568A standard. A straight cable allows signals to pass straight through from end to end. And this is the most common type of cable, and it is used to connect computers to hubs, switches, or modems. Another type of cable is called a crossover. And this cable is created when both ends of the cable are wired using the two different standards. For example, one end is wired using the A standard, and the other end is wired using the B standard. Crossover cables are used to connect two similar devices together. For example, you can use a crossover cable to connect two computers directly to each other without using a hub or a switch. Crossover cables are also used to connect hubs or switches to each other. A rollover cable is created when both ends are wired completely opposite of each other. These are used to connect a computer or a terminal to a router's console port. And a loopback cable is for testing purposes. It's to make a computer think that it's connected to a network. And to make a loopback cable, you connect pin 1 to pin 3 and pin 2 to pin 6. Now, a firewall can be either software or hardware. It is a system that is designed to prevent unauthorized access from entering a private network by filtering the information that comes in from the internet. It blocks unwanted traffic and permits wanted traffic. So basically, it filters the incoming network data packets and determines by its access rules if it is allowed to enter the network. In today's high-tech world, a firewall is essential to every business to keep their network safe. Firewalls come in different types, and one type is called a host-based firewall. And this is a software firewall. This is the kind of firewall that is installed on a computer, and it protects that computer only and nothing else. For example, later versions of Microsoft operating systems come prepackaged with a host-based firewall, as you can see here. You can turn the firewall on or off if you want, and you can also create exceptions to the firewall based on the application name on the Exceptions tab. And of course, you can always purchase a third-party firewall and install it on your computer. Today, there are several different categories of twisted pair cables that you're going to need to know for the exam. The difference between these is a maximum speed they can handle without having any crosstalk. The numbers of these categories represent the tightness of the twists that are applied to the wires. So Category 3 has a maximum speed of 10 megabits per second. Category 5 has a maximum speed of 100 megabits per second. Category 5E is an enhanced version of Category 5, and it has speeds of 1000 megabits per second. Now, Category 6 also has a maximum speed of 1000 megabits per second, but it's more of a heavier duty cable when compared to Category 5E. And it also has a maximum speed of 10,000 megabits per second, but only for a cable length of less than 100 meters. Category 6A, or Augmented, has a max speed of 10,000 megabits per second, and unlike Category 6, this has a maximum length of 100 meters. And last, there's Category 7, and Category 7 also has a speed of 10,000 megabits per second. Now, Category 7 is basically a heavy-duty version of Cat 6, with added shielding to the wires for better protection against interference. Unshielded twisted pair is by far the most common type of cable that is used today. It consists of 4 pairs of unshielded wires twisted around each other. The wires are twisted to prevent electromagnetic interference or crosstalk. This type of cabling is mainly used on local area networks. Now, shielded twisted pair is very similar to unshielded twisted pair, except that it has a foil shield that covers the wires. This shielding adds a layer of protection against electromagnetic interference leaking into or out of the cable. This is a coaxial cable. This is used today primarily by cable providers to provide a computer with broadband internet connection. Early on, it was used as a backbone for networks, such as a bus network. Now there are two common types of coaxial cable. The first type is RG6, and this is made for long distances and is commonly used for cable television and internet connection. And the second type is RG59, and this is made for short distances and is commonly used for high definition and high quality video. Now we're getting into fiber optic cables. And here is a cutaway view of a fiber optic cable and a light source. Fiber optic cable uses pulses of light to send data. And as a result, it is very fast and it can span for great distances. Now there are two different modes in fiber optics: single mode fiber and multi-mode fiber. Single mode fiber is a fiber optic cable that allows light to enter only at a single angle, as you can see here. So when this type of transmission of light enters at this angle, it can span for great distances. Now this is multi-mode fiber, and the difference between multi-mode and single mode is that in multi-mode, light travels in multiple beams that reflect off the walls of the cable. And unlike single-mode fiber, multi-mode fiber is made for short distances. Now those of you who have broadband cable internet will recognize this device. And yes, this is your typical DOCSIS cable modem. DOCSIS stands for Data over Cable Service Interface Specifications. The DOCSIS 3.1 specification supports speeds of 10 gigabit downstream and 1 gigabit upstream. The DOCSIS cable modem handles both incoming and outgoing data signals, including internet, video, and voice. A hub is a device that has multiple ports that accepts Ethernet connections from network devices. A hub is considered not to be intelligent because it does not filter any data or has any intelligence as to where data is supposed to be sent. When a data packet arrives at one of the ports, it is copied to all other ports. So all the devices on that hub sees that data packet. There are also two different types of hubs: passive and active. The difference is a passive hub does not require power, but an active hub does require power. Now a switch is very similar to a hub. It's also a device that has multiple ports that accepts Ethernet connections from network devices. But unlike a hub, a switch is intelligent. A switch can actually learn the physical addresses of the devices that are connected to it, and it stores these addresses in a table. So when a data packet is sent to a switch, it directs it only to the intended destination port. That's the major difference between a hub and a switch. So as a result, switches are far more preferred over hubs because they reduce any unnecessary traffic on the network. Bridges are used to divide a network into separate collision domains. For example, here we have a network, and this network is segmented into two by a couple of hubs. And if you notice, all the broadcast traffic from the two segments are seen by all the computers on both sides. And this causes unnecessary traffic. So that is where a bridge can be helpful. If you add a bridge to this network, it will reduce any unnecessary traffic between the two segments by filtering the data based on their MAC address. The bridge only allows data to cross over if it meets the required MAC address of the destination, because a bridge keeps a record of all the MAC addresses of the NICs that are connected to it, and it will also block all data from crossing over if it fails to meet this requirement. Now, a router does exactly what its name implies. A router is a device that routes or forwards data from one network to another based on their IP address. When a data packet is received from the router inspects the packet and determines if the packet was meant for its own network or if it's meant for another network. If the router determines that the data packet is meant for its own network, it receives it. But if it's not meant for its own network, it sends it off to another network. So a router is essentially the gateway for a network. Now let's go ahead and demonstrate this. Here we have a private network with its router, and we'll refer to this one as the red network, indicated by the red colored screens on the computers. And over here you're going to have different data packets, indicated by their various colors, and they are going to be entering the red network's router from the internet. The router is only going to accept the red data packets because they are the only ones that are intended for this network. So all of the other data packets, the yellows, blues, greens, etc., will be rejected by this router because they were not intended for this network. Now this is a very simplified illustration of how a router works, but I think you'll get the idea. Networking devices need electrical power to function, and that's why they have a separate electrical port for a power plug. But some networking devices don't have an electrical port. It's not that they don't need electrical power, it's just that they get their power and data from the same cable, which is through the Ethernet cable. And this technology is known as PoE, which stands for Power over Ethernet. A network interface card, or NIC, is used to connect a computer to a network. It is basically a circuit board with a network adapter that is installed on your computer. And its job is to convert incoming serial data into parallel data so that the computer can understand it. A NIC provides a constant dedicated connection to a network. And every NIC has its own unique identifier called a MAC address. A wireless access point is basically a wireless hub that is used by wireless devices. It connects to a wired network and relays data between the wired network and the wireless device for communication purposes. In this illustration, you see a wireless access point wired to a network so that the wireless laptop can communicate with the network. A dial-up modem is a device that allows a computer to transmit data over normal telephone lines. The data coming in from the telephone lines is analog. However, the data in a computer is all digital. So when the analog data comes in from the telephone lines, the modem's job is to convert it into a digital form so the computer can understand it. So that's basically what a modem does. It converts analog data into digital data. And the maximum speed of most modems today is 56 kbps. A patch panel is a panel that has multiple cable connections and connects incoming and outgoing patch cables in a local area network. It allows network administrators the convenience of arranging or rearranging circuits if necessary. For example, here we have a patch panel that has several UTP patch cables attached. The IEEE is an international organization for the advancement of technology related to electricity. And they are responsible for a set of standards for a project called the 802 project. And one of these standards is the 802.11 standard, which is wireless. Wireless technology is becoming more and more popular, and today there are 5 wireless standards. There are the A, B, G, N, and AC standards. And here is a chart of the speed, frequencies, and release year for each one. Starting with the first wireless standard, which is 802.11a, which came out in 1999, and the latest standard is the 802.11ac standard, which was released in 2014. Infrared is a technology that was developed by IRDA, which stands for the Infrared Data Association. The term infrared actually means below red. It's a wireless technology where data is transmitted in rays of light, rather than using radio waves. Many companies have now utilized this technology to transmit and receive data in their products. However, the drawbacks of infrared is that it requires a direct line of sight. If any object comes in between the 2 infrared devices, the communication will be blocked. And also, infrared does not work in direct sunlight. If this happens, the communication will be weakened and most likely will be blocked. Bluetooth is a short-range radio that provides a way to connect and exchange information between devices, such as laptops, cell phones, and tablets. It operates at 2.4 GHz and is capable of transmitting both voice and data. The latest standard in Bluetooth has a transfer speed of 24 megabits per second and has a maximum range of approximately 100 meters. An IP address is a numeric address. It's an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes. The IP address consists of 2 parts. The first part is the network address, and the second part is the host address. There are also 2 types of IP addresses. The first one is the most common one. It's called IP version 4. And the second type is IP version 6. IP version 4 is the current version of IP addresses. It's a 32-bit numeric address written as 4 numbers separated by periods. Each group of numbers that are separated by periods is called an octet. The number range in each octet is 0 to 255. This address version can produce over 4 billion unique addresses. When the Internet was first developed, programmers didn't realize how big it would become. They thought that IP version 4, which produced over 4 billion addresses, would be enough. But they were wrong. IP version 6 is the next generation of IP addresses. The main difference between IP version 4 and IP version 6 is the length of the address. The IP version 4 address is a 32-bit numeric address, whereas IP version 6 is a 128-bit hexadecimal address. Hexadecimal uses both numbers and alphabets in the address. So with this type of address, IP version 6 can produce an unbelievable 340 undecillion IP addresses. That's the number 340 with 36 digits after it. So as you might have guessed, IP version 6 is more than enough for the foreseeable future. As stated previously, an IP address has 2 parts. One part is designated for the network, and the remaining is designated for the host. So the way to tell which portion belongs to either the network or the host is where the subnet mask comes in. A subnet mask is a number that resembles an IP address. It reveals how many bits in the IP address are used for the network by masking the network portion of the IP address. So in this subnet mask, the first 2 octets are 255. So if we were to look at this subnet mask in binary form, the first 2 octets would be all ones, because when you count all the numbers in an octet, it will equal 255. Now let's go ahead and add our IP address with its binary form. So the way to tell which portion of this IP address is the network portion is when the subnet mask binary digit is 1, it will indicate the position of the IP address that defines the network. So we'll cross out all the digits in the IP address that line up with the ones in the subnet mask. And when you do this, it will reveal that the first 2 octets are the network portion, and the remaining is the host portion. Here is a chart of the default subnet masks for a class A, B, and C IP addresses. Notice the change of the locations of the network and host portions between them. You should memorize these default subnet mask classes. IP addresses are assigned to different organizations and blocks, and these blocks are divided into 5 classes. But for the exam, you only need to know 3 of them. They are Class A, Class B, and Class C, and you can tell by the number in the first octet which class an IP address belongs to. So a Class A IP range is from 1 to 126. This class supports 16 million hosts on 126 networks. This class is mainly given to large organizations because of the tremendous amount of IP addresses it can give out. And a Class B IP range is from 128 to 191, and this class supports 65,000 hosts on 16,000 networks. This class is given to medium-sized organizations. And a Class C IP range is from 192 to 223. This class supports 254 hosts on 2 million networks. And this class is given to small organizations. You're also going to need to memorize the default subnet masks for each of these classes. Now if you notice, we skipped over the 127 range. And that's because this number cannot be used for a network, because the number 127 address is reserved for internal loopback functions. Public IP addresses are publicly registered on the Internet, which basically means that if you have a public IP address, you have access to the Internet. But private IP addresses are different. A private IP is not publicly registered, so you cannot directly access the Internet with a private IP. So for example, let's say you have a small business and you need 10 public IP addresses so your employees can access the Internet. Now you could contact your ISP and ask them for these additional IP addresses, but that would be very expensive and unnecessary. So that's where private IP addressing comes in. In private IP addressing, you can create these 10 private IP addresses and just have one publicly registered IP address from your ISP. These 10 private IPs would then be translated into the one public IP so your employees can have access to the Internet. This not only saves money, but it also helps prevent having a shortage of public IP addresses. The RFC-1918 standard created private IP addressing to prevent a shortage of public IP addresses available to ISPs and subscribers. Private IP addresses are typically used on local networks such as homes, schools, and businesses. And these private IP ranges have 3 classes. Class A starts with the number 10, Class B starts with the number 172, and Class C starts with the number 192. Every computer on the network has to have an IP address for communication purposes, and there are two ways that a computer can be assigned an IP address. It can be done either by using a dynamic IP or a static IP. A dynamic IP is where a computer gets an IP address automatically from a DHCP server. DHCP stands for Dynamic Host Configuration Protocol. A DHCP server automatically assigns a computer with an IP address. And in addition to an IP address, it can also assign a subnet mask, default gateway, and a DNS server. Here we have the TCP/IP properties window open for the network interface card on a Windows machine. And as you can see, this computer is set to obtain an IP address automatically. So when you choose this option and press OK, the computer will send out a request for an IP address. Then the DHCP server will assign an IP address from its pool and deliver it to the computer. Dynamic IP addressing is the best choice because it makes managing a network a lot easier. You can also assign a computer with an IP address manually, and this is called a static IP. A static IP is where a user manually assigns an IP address for the computer, so there is no need for a DHCP server. And this kind of IP addressing is also known as permanent, because unlike dynamic addressing, where the IP address can change automatically, a static IP only changes if the user decides to. When a computer is set to automatically obtain a dynamic IP address, it gets the IP from a DHCP server. But what happens if this computer cannot reach a DHCP server? For instance, what happens if the DHCP server goes down, or if the connection to the server is lost? If this happens, then the computers that are running Microsoft Windows 98 or later, the computer itself will assign its own IP address. This IP address will be in the 169.254.0.0 network. And this type of self-assigned addressing is called API-PA, which stands for Automatic Private IP Address Assignment. Computers running Microsoft Windows 98 or later do this so they can still be able to communicate with other computers on the same network that also have self-assigned IP addresses. If a DHCP server later becomes available, the computer changes its IP address to one that's obtained from a DHCP server. Problems can also happen in DHCP. For example, what would happen if a DHCP server was removed? If this were to happen, then certain computers that have an expired IP address would not be able to renew their IP lease, because there is no longer a DHCP server present. So these computers won't be able to access the network. This would also affect when new computers are added. They will not be able to access the network without an IP address. It's important to remember that this is only the case if the computers were configured to obtain an IP address automatically. So this would have no effect if they were configured for a static IP. So in another scenario, what would happen if another DHCP server was added to the network? So it's important to remember that if you're going to add another DHCP server to the network, that it must be configured properly. For example, you're going to have to make sure that the two DHCP servers do not give out the same IP address to a computer, because all IP addresses must be unique. And if the second DHCP server assigns an IP address that is already in use, an IP address conflict will happen. So to avoid this, you must configure the address pool correctly. Transmission Control Protocol is one of the main protocols used in a TCP/IP network. Now this is a connection-oriented protocol, which basically means that it must first acknowledge a session between the two computers that are communicating. And it does this by using a three-way handshake. The first step is that a computer will send a message called a SYN, S-Y-N. Then the receiving computer will send back an acknowledgement message telling the sender that it has received the message. And finally, the sender computer sends another acknowledgement message back to the receiver. And once this has taken place, data can be delivered. Another important thing to remember about TCP is that it guarantees the delivery of the data. So if a data packet goes astray and doesn't arrive, then TCP will resend it. Now UDP is very similar to TCP. UDP is also for sending and receiving data, but the main difference is that UDP is connectionless, which means that it does not establish a session and does not guarantee data delivery. So when a computer sends their data, it doesn't really care if the data is received at the other end. And that's why UDP is known as a fire and forget protocol, because it sends data and it doesn't really care what happens to it, as this demonstration will show. Another point to remember is that because of the less overhead that's involved of not guaranteeing data delivery, UDP is faster than TCP. DNS stands for Domain Name System. Now this resolves domain names to IP addresses. In the world of networking, computers don't go by names like humans do. They go by numbers. So if you type in a web address in your web browser, DNS will transform the name to a number, because all computers know are numbers. So for a demonstration, when you type in yahoo.com in your web browser, the DNS server will search through its database to find a matching IP address for that domain name. And when it finds it, it will transform that domain name to the IP address of the Yahoo web server. So DNS basically works like a phone book. When you want to find a phone number, you don't look up the number first. You look up the name first. Then it will give you the number. This is called Network Address Translation, or NAT. And this is a service that is typically used in routers. And this is used to translate a set of IP addresses to another set of IP addresses. So for example, here we have a private network, and it's using a set of private IP addresses internally. Over here we have the router with its public IP address. And this router is running the NAT service. If a computer in this network wanted to communicate over the internet, it needs to translate its private IP address to the internet's public IP address. And this goes both ways. If a computer on the internet wants to communicate with a computer on this private network, then the public IP address needs to be translated to the private IP address for that computer. FTP stands for File Transfer Protocol, and this is the standard protocol that is used by web users to upload and download files between computers through the internet. So if a user wanted to make their files available to download to other users, all they would have to do is simply upload their files to an FTP server, and then a user can simply download them. Now there are a few ways to transfer files using FTP. You can use your standard internet browser, or you can use special FTP software. It is also important to note that FTP is a connection-oriented protocol that uses TCP for file transfer. TFTP stands for Trivial File Transfer Protocol. And this is a very simple transfer protocol. It is not used to transfer files over the internet like FTP does. It's mainly used for transferring files within the same network, and it does not provide any security during the transfer. And unlike FTP, that uses the TCP protocol for file transfer, TFTP is a connectionless protocol that uses UDP as its transfer protocol. Now, secure FTP is just like FTP, except that it adds a layer of security. The data using secure FTP is actually encrypted using secure shell during data transfer. So no sensitive data like passwords are sent in clear text. SMTP stands for Simple Mail Transfer Protocol. Now this, as you might have guessed, is the protocol that is used to send email. A good way to remember this is by looking at the acronym SMTP and translating that to sending mail to people. SMTP uses the TCP protocol, and as you know by now, it is connection-oriented. So if an email you send does not reach its destination, you'll get that familiar mail delivery error in your mailbox, informing that the email you sent failed. Where SMTP is used for sending email, POP3 is the protocol that is used for receiving email. Whenever an email arrives at your mail server, you can retrieve it using the POP3 protocol and download it to your computer. The main characteristic about POP3 is that all it does is grab the email from the mail server and downloads the email to your computer. It does not sync any email or folders from the mail server and your computer like IMAP4 does, which we'll talk about next. It strictly downloads the email. And typically, when your email application using POP3 retrieves the email from the mail server, the email is removed from the mail server, unless you specify in your email application to keep a copy on the mail server. POP3 is commonly used with email applications such as Microsoft Outlook. IMAP4 is another protocol that is used for receiving email. IMAP4 is similar to POP3 because they are both used for retrieving email from a mail server. But IMAP4 has better features. With IMAP4, you can access and manage your email on the server from your local computer. So if you wanted to read your email and keep a copy of it on the server, IMAP4 will allow you to do just that. And unlike POP3, IMAP4 syncs your email and your email folders from the mail server with your computer. And IMAP4 is also commonly used with Microsoft Outlook. HTTP stands for Hypertext Transfer Protocol. Now this is probably the most widely used protocol in the world today. HTTP is the protocol that is used for viewing web pages on the internet. So when you type in a web address, for example google.com, you'll notice that HTTP is added at the beginning of the URL. And this indicates that you are now using HTTP to retrieve this web page. In standard HTTP, all information is sent in clear text. Now normally this would be okay if you were just browsing regular websites. But if you were at a website where you had to enter sensitive data, such as passwords or credit card information, then this would be a problem as far as security. HTTPS stands for Secure Hypertext Transfer Protocol, and this is HTTP with a security feature. HTTPS encrypts the data that is being retrieved by HTTP. So for example, If you wanted to go to your bank's website to check your account, you will notice that an S will be added to the HTTP in the web URL. And this indicates that you are now using HTTPS and have entered a secure website where sensitive data is going to be passed, and that data needs to be protected. Some other examples where HTTPS is used would be like email servers or e-commerce websites. Telnet is a terminal emulation program that is used to access remote servers. It's a simple tool that runs on your computer, and it will allow you to send commands remotely. And because it only sends commands and not graphics, it's very fast. But the drawback is that it's not secure. All commands are sent in clear text. So today, Telnet is mainly used to access devices within a local network and not on the internet. Now, SSH or Secure Shell is a better alternative to Telnet. Secure Shell protects the data from being attacked or stolen as it's being transferred over a network. So for example, if you were sending sensitive data like a login and password, a potential hacker could be listening and steal the data. And that's the reason for Secure Shell. Secure Shell acts like a secure tunnel that forms around the data transfer and protects it from potential threats. And this is called Simple Network Management Protocol. And this is a protocol used for network management. It's basically used for collecting data from various network devices, such as routers, printers, and servers. When data is sent over the internet to your computer, it needs to know how to accept it. And your computer accepts this data using ports. And these ports are categorized by two protocols, TCP and UDP. Now, a port is a logical connection that is used by programs to exchange information. And these ports have a unique number that identifies them. The number ranges from 0 to 65535, but for the exam, you only need to know a few of them. So here is a chart of the ports that you need to know for the exam. Some of these ports are very common and are used every single day, such as port 80, which is used for bringing up web pages on the internet. Another one is port 443, which is used for logging into secure web pages that require a login and password. And another common one is port 25, and this is used for sending email from an email application such as Microsoft Outlook. DSL stands for Digital Subscriber Line, and this is a popular technology that is used by homes and businesses to access broadband data over the internet. The advantage of DSL is that it can carry both voice and data at the same time. It has a DSL modem that uses common telephone lines to carry its data. It's a high-speed connection that is much faster than your regular dial-up modems. There are a few different forms of DSL, and one is called ADSL, which stands for Asymmetric Digital Subscriber Line. And this is called asymmetric because the download speed is considerably faster than the upload speed. This type of DSL is typically used in homes and is the cheapest form of DSL. SDSL stands for Symmetric Digital Subscriber Line. And as the name implies, the download and upload speeds are the same. This type is typically used in businesses. And VDSL stands for Very High Bit DSL. And this is a very fast form of DSL. It has download speeds of over 50 megabits per second over copper wire. But because it uses copper wire, it's only made for short distances. For long distances, it can also use fiber optic cable. Another popular technology that is used to access the internet is broadband cable. Cable is by far becoming the technology of choice by many homes to access the internet. It uses a cable modem with an attached coaxial cable, which provides a link to the internet service provider. Like DSL, cable is very fast, with speeds of 50 megabytes or more. Cable is typically provided by the same provider that provides cable television to their customers. POTS/PSTN stands for Plain Old Telephone Service and Public Switched Telephone Network. And these are just your plain old telephone lines. And these are slowly becoming obsolete by people who use the internet because of their slow speeds. So if you have ever used a high-speed internet, such as broadband, you will never go back to using the slow speeds of 56K, which is the speed of a standard dial-up modem. However, telephone lines do have an advantage, and that is that they are basically everywhere, and they are fairly cheap to use. ISDN stands for Integrated Services Digital Network. This is an international standard for digital transmission over ordinary telephone lines. In order to use ISDN, users had to install ISDN modems. This was a significant improvement of speed over the standard modem, because a standard modem sends data at a maximum speed of 56 kbps. But ISDN sends data at 128 kbps. But ISDN never really caught on because of the faster speeds of DSL and cable. Satellite communication is pretty expensive, and it's mainly used where no other services are provided, like phones, cable, or DSL. But because of the increasing availability of these other options, satellite is rarely used. The speed of satellite has increased throughout the years, with speeds maxing out around 15 megabytes per second, with only a fraction of that in upload speeds. Another method of connecting to the internet is by using mobile hotspots. And mobile hotspots are portable devices that use cellular networks to connect wireless devices to the internet. So if there are wireless devices within 30 feet of the mobile hotspot, they can join it, and then they will have access to the internet. Mobile hotspots come in two forms. They will either be a freestanding device like you see here, or they can come as a feature built into a smartphone. And mobile hotspots are available through cell phone carriers, such as Verizon, AT&T, T-Mobile, and Sprint. The word PAN stands for Personal Area Network, and this is a type of network that is used on a personal level. It's a small network that is basically used for connecting things like mobile phones, PDAs, and laptops to each other using Bluetooth. PANs are generally used for transferring small files, such as music, photos, calendar appointments, and so on. Now, a LAN stands for Local Area Network. And a local area network is a group of devices, such as computers, servers, and printers, that are basically located in the same building. In other words, in close proximity to each other. The most common type of LAN is an Ethernet LAN, where two or more computers are connected to Cat5 Ethernet cables using a switch. A MAN stands for Metropolitan Area Network. Now this is a larger network than a LAN. It's a network that spans over several buildings in a city or town. MANs are typically connected using a high-speed connection such as fiber optic cable. And finally, there is the Wide Area Network, or WAN. And a WAN is the largest type of network. It's a network that spans over a large geographical area, such as a country, continent, or even the entire globe. A good example of a wide area network is the Internet. If you're already a network administrator, then the most common tool that you have probably used is the wire crimper. And this tool is used to make custom length network cables. It crimps adapters such as the RJ45 to twisted pair cables. So after you have attached your RJ45 adapter to your cable, you just place it into the crimper, give it a squeeze, and the cable is done. A punch-down tool is a tool that resembles a screwdriver, and this is simply used to connect or punch wires to a punch-down block. Another network tool is a media tester. So after making a custom length cable using your wire crimper, it's a good idea to test the cable to make sure it's wired correctly. So you would just connect both ends of the cable into the tester, and then the tool will check the cable for you. The plastic shielding around a network cable must be removed in order to crimp a connector. And this is done by using a cable stripper. The cable is then inserted into the tool, and then the outer plastic shielding is removed. A multimeter is a device that is used to test electrical circuits. It's a popular tool that is used for many different trades. It can measure voltage, resistance, current, and continuity, just to name a few. And it comes in both analog and digital versions. And this tool is called a tone generator. And this is also known as a fox and hound. Now this tool is used for locating cables from one end to the other. So for example, if you suspect that you have a bad cable that was grouped with a lot of other cables, and that group was stressed over a long distance, it would be very difficult to isolate one end of the cable from the other. So that's where a tone generator comes in. So you just connect the tool at one end, and then it would generate a tone through the cable, where the other part of the tool would detect the sound and pinpoint the cable. Next, we're going to talk about SOHO routers, which stands for Small Office Home Office Router. And these are your common inexpensive routers that are used in homes and small businesses. These are fairly easy to set up, but if you don't configure the router correctly, you will not have access to the network. To set up and configure your SOHO router, you need to go into the router's built-in configuration web page. So you would just open up a web browser, and in the address field, you would type in the router's IP address. So for example, our router has an IP address of 192.168.2.1. And once you type that in, you press enter on your keyboard, and now you're in. So here's an example of the configuration page for a Cisco SOHO router. And this is where you would set up the router with custom settings to make it work for your particular network. So for example, like most SOHO routers, this one has a DHCP server built into it. And as you recall, a DHCP server automatically assigns an IP address to each computer on your network, because all computers need an IP address to function on a network. So by default, the DHCP server is enabled. But if you want to, you can disable the DHCP server by pressing this button here, and then just save your settings. Also on a router's web page, there are the wireless settings. Now in here, you can configure the wireless settings for your network. For example, you can set the SSID, which stands for Service Set Identifier, which is basically the name of your wireless network. The SSID is shared among all wireless devices in your network. The SSID is customizable, and you can call it whatever you want. And as you can see here, this SSID is called My Wireless. So as an example, when a wireless laptop scans for wireless networks to join in the vicinity of this router, the laptop will see the router's SSID broadcast called My Wireless, and if it has the proper credentials, it can join the network. Also in here, you can set the channel for your wireless network. And channels are used to avoid interference with other wireless networks nearby. So if you are experiencing any connectivity issues to your wireless router, there might be interference with another nearby wireless network that's operating on the same channel as yours. So in this case, you can try changing to a different channel and see if it solves your problem. And if you click on the wireless security section, you can configure the security of your wireless network. So here you can choose to disable security and have your network wide open, or you can choose to secure your network with one of these security modes. And as you can see, this router supports the following security options, such as WEP, WPA, and WPA2. Wired equivalent privacy is one of the security protocols that are used for wireless networks. And as its name implies, it's meant to supply the same security to wireless networks as it did for wired networks. But this turned out not to be the case. After time, it was found out that the 40-bit encryption key that WEP used was not secure and it was easily hackable. So a better security protocol was needed for wireless. WPA is another wireless security protocol that was developed to solve the security problems of WEP. WPA is far better than WEP in two ways. First, it uses a stronger encryption method using TKIP, which stands for Temporal Key Integrity Protocol, which dynamically changes keys as it's being used. This ensures data integrity. And secondly, WPA uses EAP, which verifies authorized network users. Building on the security of WPA, WPA2 was developed to provide even stronger security than WPA. And it does this by requiring the use of a stronger wireless encryption method. While WPA uses Temporal Key Integrity Protocol for encryption, which has known to have some limitations, WPA2 uses CCMP for encryption. And CCMP is more secure because it uses an enhanced data cryptographic encapsulation mechanism. And since 2006, WPA2 is available on all certified Wi-Fi hardware. And our last wireless security protocol is WPS. WPS stands for Wi-Fi Protected Setup. And this security protocol was designed for users who know little about wireless networks to make it as easy as possible for them to join a secure wireless network. So here's an example of a WPS configuration page for our router. And as you can see, there are 3 different WPS methods that you can use to join this wireless network. So you could use method 1 if your client has a Wi-Fi protected setup button. You would just press that button, then within 2 minutes you would press the WPS button here on this page, or you can just press the physical WPS button on the router itself, and then you'll be connected. You can also use method 2 if your client has a WPS PIN number. You would just enter that number in here and press register. Or you can use method 3 if your client asks for the router's PIN number, and you would just enter this number into your device, and then you'll be connected. So as stated before, WPS is the easiest way to join a wireless network, and a lot of manufacturers are building their wireless products with WPS to make it as simple as possible for their customers to join their device to a wireless network. Another wireless security is the MAC filter. Every wireless adapter has a MAC address. A MAC address is a hexadecimal number that uniquely identifies each device on a network. And with a MAC filter, you can either prevent or permit access by using the device's MAC address. So in this example, once we enable the MAC filter, we can choose the option to prevent devices that are listed below from accessing the wireless network. So all of these devices listed here are now blocked from joining the network. Or the other option, we can choose the permit option, and this will allow only the devices listed below access to the network. There is also what's called the DMZ, and DMZ stands for Demilitarized Zone. And the DMZ allows a designated computer on your network to be fully exposed to the internet. And it does this by the router forwarding all ports at the same time to the designated DMZ computer. So while these computers here on our internal LAN are protected inside the firewall, the DMZ computer is outside the firewall and is not protected. The DMZ is typically used for testing purposes. So if you just set up a computer that you want to be accessed from the internet, and if you're having a problem configuring the firewall and applications so that it can be accessed from the internet, you can simply bypass all firewall security and put the computer in the DMZ temporarily to make sure everything is working until you can pinpoint a problem you are having, such as a firewall setting. It's also important to note that the DMZ computer must be assigned a static IP address and not automatically from a DHCP server. Another option on the configuration page is port forwarding. And on this page, you can customize port services for certain applications. So when a user sends these types of requests to your network from the internet, the router will forward those requests to the appropriate computer. So for example, let's say a friend of yours wants to access one of your computers in your home network using RDP or Remote Desktop Protocol. And as you know from an earlier lesson, that RDP services uses port 3389. So what happens is, when your friend starts up their RDP service on their computer, they put in the public IP address of your router, and once that request hits your router needs to know which computer on your network to forward that request to, so your friend can access the correct computer. So that's where port forwarding comes in. Here on the port forwarding configuration page, you have to forward the RDP port to the correct computer. So you type in the RDP port number, which is 3389, and then you have to point it to the IP address of the computer that you want your friend to access, which is 192.168.2.3. And once that's done, the router knows where to forward that request, and the connection is now complete. The ping command is the most widely used of all network utilities. It's a tool that is used to test issues such as network connectivity and name resolution. So for example, let's go ahead and ping a host IP address. So at a command prompt, you would type ping space, then the IP address, and then press enter. Now it's going to send out 4 data packets to the destination IP address we chose. Then the destination will send the data packets back to us as a reply. And these replies are called echo reply requests. And these replies will inform you about what's happening with the destination host we pinged. For example, if we received a reply, then that means that there is general network connectivity between us and the destination. But if we did not get a reply, then that means that there is no reply from the host, and it could mean that there is no network connectivity between us. But if we pinged the host and we got a message that says request timed out, then that could mean that the host is down, or that it's blocking all ping requests. Or after we pinged and we got a message that says destination host unreachable, then that message is coming from a router, and it means that a route to the destination cannot be found. The ping command can also be used to test DNS name resolution issues. For example, before we used the ping command with an IP address, but we could also use it with a domain name. For example, we could type ping space then the domain name yahoo.com. So if by pinging the domain name, and if we got the same successful result as typing the IP address, then this would indicate that the name resolution by DNS is working fine. But let's just suppose that the domain name ping failed. Then the next step will be typing the IP address instead. So if by typing the IP address, and if the ping was successful this time, then we now know that we are having a problem with DNS. The ping command can also be combined with other subcommands called switches. And switches are used to alter the parameters of the ping utility. And you can view a full list of these switches by typing ping space / and then a question mark. Our next utility is called trace-RT, which stands for trace route. And this is used to find out the exact path the data packet is taking on its way to the destination. So for example, let's go ahead and trace the route from our computer to another computer. So at a command prompt, we would type trace-RT space and then the IP address and press enter. Now the data packet will find its way to the destination, and each time it reaches a router on its path, it will report back information about that router, such as the IP address and the time it took between each hop. So the trace-RT utility is a great tool that can be used to pinpoint where a problem lies on a network if a data packet cannot reach the destination. So for example, if we try to ping a destination and the ping command failed, we can use the trace-RT utility to find out where the data packet is failing along its path. So let's go ahead and trace route this IP again. And let's suppose that this time there was a problem. So let's type in trace-RT, then the IP address, and as the data packet goes on its path, it'll tell us at which area the problem lies. And the data packet stops right here. So the trace-RT utility has isolated that the problem is somewhere between these two routers. And this is the MBT-stat utility, and this is used to resolve net BIOS names to IP addresses. So at a command prompt, just type in NBT-stat, and here is an example of the result. This is probably the least common utility that you will ever use. Our next utility is called netstat. Now this is a very useful tool, and it's used to display current network connections to your computer. So in our example here, we can visually see that our computer is currently communicating with an FTP server and 2 HTTP web servers. And we can verify this by using the netstat utility. So at a command prompt, we type netstat, and in this case we're going to use a -A switch, and then press enter. Now in our display, we can see the 2 HTTP servers and the FTP connection. So even if you're not sure what connections your computer currently has, you can use the netstat utility to find out. And in addition to connections, it also displays which ports are open and listening for a connection. The ipconfig utility is very common. This utility is a powerful tool used to display network configuration for our computer, and this information can be used for problem solving. So for example, if we open up a command prompt and type in ipconfig along with the /all switch, then this will display the full TCP IP configuration for our computer, such as our computer name, MAC address, IP address, default gateway, which is the router, DNS servers, and so on. And by using this information, we can find solutions if we are experiencing problems. For example, if we had a problem with our IP address, we can see from this information that DHCP is enabled, which means that this computer is getting its IP address from a DHCP server. And it also tells us the IP address for the DHCP server. It also tells us the IP address for the DNS server. So if we're experiencing any problems browsing the internet with domain names, then there might be a problem with the DNS server itself. Using the ipconfig utility by itself displays the IP address, subnet mask, and default gateway. But using this utility when combined with subcommands called switches changes the output slightly. So for example, when we use ipconfig combined with a /all, which we just used in our previous slide, it displays the full TCP IP configuration for our computer. When we use ipconfig /renew, this releases and renews the IP address lease given to us from the DHCP server. And ipconfig /release releases the IP address but does not renew it. To see a complete list of all the switches that can be used with ipconfig or any command utility, just type in the name of the utility, space, and put a / and a question mark. And that'll show you all the switches that are available. And similar to the ipconfig utility that's used in Windows, there is also the ifconfig utility. And the ifconfig utility is a command that's used in Unix and Linux operating systems. And it displays configuration information from the network interface card, such as the IP address, subnet mask, how many packets it has received and sent, any errors, and so on. And like ipconfig, it can also be combined with switches on the end to alter the output. And our last utility is called NSLOOKUP. This name is short for Name Server Lookup, and this utility is used to look up DNS information. So for example, at a command prompt, if you type in NSLOOKUP along with a domain name such as yahoo.com, the result will give you the DNS information for the Yahoo domain. And the dig command is the Unix version of NSLOOKUP. It does the same thing.